Welcome to this space, where each night we journey through the wonders and challenges of our planet. Together, we reflect on Earth's story, humanity's impact, and the paths that lie ahead. May your night be calm, your rest be deep, and your dreams gentle. Remember to subscribe, so I can accompany you every night on this journey of reflection and discovery. Chapter 1. Earth, a unique planet. In the vastness of the cosmos, where billions of stars shine in the frozen void of space, there exists a small blue dot that defies all odds, an oasis of life amid infinite darkness. Earth, our home, is the only known planet where life has flourished for more than 3.5 billion years. From space, Earth appears as a jewel suspended in the black velvet of the universe. Its blue oceans reflect the sun's light, while swirling white clouds dance across continents painted in shades of green and brown. This is our pale blue dot, as Carl Sagan called it, a mote of dust suspended in a sunbeam, yet containing everything we have ever known or loved. But what makes Earth truly extraordinary is not just its beauty, but its remarkable ability to sustain life. For millions of years, our planet has operated as a self-regulating system, maintaining the delicate balance necessary for life to thrive. The atmosphere, oceans, land, and living organisms work together in an intricate dance of chemistry and physics that scientists call the Earth system. This extraordinary planet exists in what astronomers call the Goldilocks zone, not too hot, not too cold, but just right for liquid water to exist on its surface. Our distance from the Sun, approximately 93 million miles, creates the perfect conditions for life as we know it. Too close, and water would boil away like on Venus, where surface temperatures reach 900 degrees Fahrenheit. Too far, and everything would freeze solid like on Mars, where the thin atmosphere cannot retain enough heat to sustain liquid water. But Earth's habitability depends on far more than just distance from the Sun. Our planet's magnetic field, generated by the motion of molten iron in its core, shields us from deadly solar radiation that would otherwise strip away our atmosphere and sterilize the surface. The Moon, our celestial companion, stabilizes Earth's axial tilt, preventing extreme climate variations that would make complex life impossible. Even our atmosphere's composition, 78% nitrogen, 21% oxygen, and trace amounts of other gases, including the crucial 0.04% carbon dioxide, represents a perfect recipe for life. This system is powered by the sun's energy, which drives the water cycle that brings rain to nourish the land and creates the winds that circulate nutrients around the globe. Every day, the sun delivers more energy to Earth in 1 hour than humanity uses in an entire year. Plants capture this solar energy through photosynthesis, the miraculous process that converts sunlight, water, and carbon dioxide into the sugars that form the foundation of virtually all life on Earth. As a byproduct, photosynthesis releases oxygen into the atmosphere while absorbing carbon dioxide, creating the breathable air that sustains us. Ocean currents transport heat from the equator toward the poles, moderating global temperatures and creating the climate zones that support different forms of life around the world. The Gulf Stream alone transports more heat northward than all the world's power plants combined, keeping Western Europe 10-15 degrees warmer than it would otherwise be. Without these massive conveyor belts of warm water, London would have the climate of northern Canada. Ice caps reflect sunlight back to space, preventing the planet from overheating through a process called the albedo effect. The brilliant white surfaces of ice and snow can reflect up to 90% of incoming solar radiation, compared to dark ocean water which absorbs 90%. This creates a powerful feedback mechanism. When ice melts, darker surfaces are exposed, which absorb more heat, causing more ice to melt. The The carbon cycle moves this essential element through rocks, oceans, atmosphere, and living organisms in a complex web of interactions that has kept Earth's temperature within the narrow range suitable for liquid water, and therefore life, for billions of years. Carbon atoms in your body may once have been part of a dinosaur, a tree, or dissolved in ancient seas. This element cycles endlessly through the biosphere, sometimes spending years in the atmosphere as CO2, centuries in wood, millennia in soil, or millions of years locked in rock formations. When volcanic eruptions released massive amounts of carbon dioxide in the past, the planet's natural systems gradually absorbed the excess through weathering of rocks and increased plant growth. When ice ages locked water in glaciers, sea levels dropped by hundreds of feet, exposing new land and altering ocean circulation patterns. Through it all, life adapted, evolved, and diversified, creating an ever more complex web of interactions. Forests grew and spread across continents, creating vast green lungs that breathed with the rhythm of the seasons. A single large tree can absorb 22 tons of CO2 over its lifetime, while releasing enough oxygen for 2 people to breathe for a year. The Amazon rainforest alone contains more than 400 billion trees, representing nearly 10% of all plant biomass on Earth. These forests regulate local rainfall patterns, cool the air through evapotranspiration, and create their own weather systems. Coral reefs built underwater cities of incredible biodiversity, supporting 25% of all marine species, despite covering less than 1% of the ocean floor. These living limestone structures, built by tiny animals over thousands of years, create complex three-dimensional habitats that rival tropical rainforests in their species richness. A single reef can support 4,000 species of fish, 700 species of coral, and countless other forms of marine life. Wetlands filtered water and provided nurseries for countless species, removing pollutants and excess nutrients while storing vast amounts of carbon in their waterlogged soils. Though they cover only 6% of Earth's surface, wetlands store 30% of all soil carbon. They serve as kidneys for the planet, cleaning water naturally and providing flood control that saves billions of dollars in damage annually. Grasslands supported great herds of migrating animals in one of nature's most spectacular displays. The Serengeti migration involves over 1.5 million wildebeest, 400,000 zebras, and 300,000 gazelles in a circular journey that has continued for millions of years. These grasslands store more carbon below ground than above, with root systems that can extend 15 feet deep, making them incredibly resilient to drought and fire. Each ecosystem played its role in maintaining the planetary balance through countless interactions and feedback loops. When one system was stressed, others compensated. When climate shifted gradually, species migrated and adapted. The whole was greater than the sum of its parts, creating a self-regulating planetary system that maintained conditions suitable for life. This is the world that gave birth to humanity, a world where natural systems had reached a state of dynamic equilibrium, constantly adjusting and readjusting to maintain conditions suitable for life. For nearly all of human history, we lived within this system, taking what we needed while the planet's vast regenerative powers healed any damage we might cause. Indigenous cultures around the world developed worldviews that recognized this interconnectedness. Australian Aborigines developed songlines, paths across the land that recorded the creation stories and navigation routes in song, preserving ecological knowledge for 65,000 years. Native Americans spoke of the 7-generation principle, considering the impact of decisions on descendants 7 generations in the future. Indigenous Amazonian peoples cultivated forest gardens so sophisticated that they created islands of enhanced biodiversity that persist today. These cultures understood that humans were part of nature, not separate from it. They developed practices that worked with natural cycles rather than against them, rotating crops to maintain soil fertility, managing fires to prevent larger blazes, harvesting resources sustainably to ensure they would be available for future generations. They recognized the sacred in the natural world and understood that the health of the land was inseparable from the health of the people. But in the grand timeline of Earth's history, human civilization as we know it represents the smallest fraction of time, a mere blink in the planet's ancient story. If Earth's 4.6 billion year history were compressed into a single year, modern humans would appear only in the final minutes before midnight on December 31st. Agriculture would begin just 30 seconds before the new year, and the Industrial Revolution would occur in the last tenth of a second. For most of our existence as a species, we lived lightly on the land, leaving footprints that would disappear with the next rain or season. Our ancestors were gatherers and hunters who followed the rhythms of nature, migrating with the seasons and the availability of resources. We were participants in Earth's symphony, not conductors attempting to rewrite the score. The planet that sustained us was resilient, beautiful, and seemingly infinite in its ability to provide what we needed. Rivers ran clean and clear, supporting salmon runs so massive that their bodies would turn entire streams silver during spawning season. The air was pure enough to breathe deeply without concern, free from the cocktail of industrial pollutants that now characterizes urban atmospheres. Forests stretched beyond the horizon in every direction. When European explorers first arrived in North America, they found forests so vast and dense that, according to legend, a squirrel could travel from the Atlantic coast to the Mississippi River without ever touching the ground. These ancient forests were cathedrals of biodiversity, with trees that had been growing since before the fall of the Roman Empire. The ocean teemed with life so abundant that early explorers wrote of waters so thick with fish that boats could barely move through them. Cod were so numerous off the coast of Newfoundland that John Cabot reported in 1497 that his crew could lower baskets into the sea and pull them up full of fish. Oyster reefs in the Chesapeake Bay were so extensive they posed hazards to navigation, filtering the entire bay every few days and supporting vast populations of fish, crabs, and birds. This was a world where the aurora borealis danced across unpolluted skies, visible as far south as Rome and the Caribbean during periods of high solar activity, where countless stars were visible on clear nights, with the Milky Way casting shadows on moonless evenings, where the silence of wilderness was broken only by the calls of wild animals, the howl of wolves, the bugle of elk, the songs of millions of birds that darkened the sky during their migrations. It was a world where the changing seasons brought predictable patterns of weather, where farmers could count on regular rains and moderate temperatures based on thousands of years of accumulated wisdom, where the great currents of air and water followed ancient pathways around the globe, creating climate patterns that remained stable for millennia. The night sky told stories that remained consistent across generations, with constellations serving as calendars and navigation guides. The first frost, the return of migrating birds, the flowering of specific plants, all these natural events occurred with clockwork regularity that allowed human cultures to develop sophisticated agricultural and social systems. Today, that harmony faces its greatest challenge in planetary history. Not from an asteroid impact that ended the age of dinosaurs, not from massive volcanic eruptions that triggered previous mass extinctions, but from a single species that has learned to harness the power of fossil fuels and transform the very chemistry of the atmosphere. That species is us. The story of Earth in the 21st century is the story of a planet in transition, a world where the stable conditions that allowed human civilization to flourish are giving way to a new and uncertain future. It is a story of unprecedented human power and equally unprecedented responsibility. It is the story of a species that must choose between destruction and hope, between the end of the world as we know it and the beginning of something entirely new. We have become a geological force equal to volcanoes, earthquakes, and ice ages. Our influence can be measured in the chemistry of the atmosphere, the temperature of the oceans, the height of the sea level, and the extinction rate of species. We have the power to alter planetary systems that took billions of years to evolve. This is our moment in Earth's long history. This is our choice to make. And the clock is ticking, measured not in geological time but in human decades. The decisions we make in the next few years will determine the trajectory of our planet for centuries to come. The Earth that gave us birth, the Earth that sustained us through our entire evolutionary history, the Earth that provided the stable climate within which human civilization could flourish. That Earth is changing. The question is what it will become, and whether human civilization can adapt to the new world we are creating. This is our moment. This is our test. This is our choice to make. And the clock is ticking. Human civilization, as we know it, represents the smallest fraction of time, a mere blink in the planet's ancient story. For most of our existence as a species, we lived lightly on the land, leaving footprints that would disappear with the next rain or season. We were participants in Earth's symphony, not conductors attempting to rewrite the score. The planet that sustained us was resilient, beautiful, and seemingly infinite in its ability to provide what we needed. Rivers ran clean and clear. The air was pure enough to breathe deeply without concern. Forests stretched beyond the horizon. The ocean teemed with life so abundant that early explorers wrote of waters so thick with fish that boats could barely move through them. This was a world where the aurora borealis danced across unpolluted skies, where countless stars were visible on clear nights, where the silence of wilderness was broken only by the calls of wild animals. It was a world where the changing seasons brought predictable patterns of weather, where farmers could count on regular rains and moderate temperatures, where the great currents of air and water followed ancient pathways around the globe. Today, that harmony faces its greatest challenge in planetary history, not from an asteroid impact or volcanic catastrophe, but from a single species that has learned to harness the power of fossil fuels and transform the very chemistry of the atmosphere. That species is us. The story of Earth in the 21st century is the story of a planet in transition, a world where the stable conditions that allowed human civilization to flourish are giving way to a new and uncertain future. It is a story of unprecedented human power and equally unprecedented responsibility. It is the story of a species that must choose between destruction and hope, between the end of the world as we know it and the beginning of something entirely new. This is our moment in Earth's long history. This is our choice to make. And the clock is ticking. Chapter 2. The beginning of the human footprint. The transformation began not with a bang, but with the steady rhythm of steam engines and the glow of coal-fired furnaces. In the late 18th century, in the industrial towns of Britain, humanity took its first steps toward fundamentally altering the planet's atmospheric chemistry. What started as local pollution from factories and mills would eventually become a global force capable of changing the very climate of Earth. James Watt's improvement of the steam engine in 1769 marked the beginning of humanity's addiction to fossil fuels. For the first time in history, humans could harness energy sources beyond muscle power, wind, and flowing water. Coal, abundant beneath the hills of England, became the fuel that powered textile mills, iron foundries, and the first locomotives. The black smoke that poured from countless chimneys was seen as a sign of progress and prosperity, not as the beginning of a planetary crisis. The Industrial Revolution marked the moment when human beings began to unlock the vast stores of carbon that had been buried beneath the Earth's surface for millions of years. Coal, oil, and natural gas, the compressed remains of ancient forests and marine organisms, suddenly became the foundation of a new kind of civilization. These fossil fuels represented the accumulated solar energy of hundreds of millions of years, captured by prehistoric plants and animals, and stored in geological formations. A civilization powered not by the daily income of solar energy captured by plants and animals, but by the geological savings account of carbon that had been accumulating for eons. We were no longer limited by the annual productivity of ecosystems, but could tap into energy reserves that represented entire geological epochs. A single gallon of gasoline contains the energy equivalent of about 500 hours of human labor, explaining why fossil fuels revolutionized human productivity and prosperity. Before 1750, the concentration of carbon dioxide in Earth's atmosphere had fluctuated naturally between about 180 and 300 parts per million over hundreds of thousands of years. These fluctuations corresponded with ice ages and warm periods, but they occurred gradually, over timescales measured in millennia that allowed ecosystems and species to adapt through migration, evolution, and gradual adjustment to new conditions. The planet's natural carbon cycle had maintained a delicate balance, with carbon moving slowly between rocks, oceans, atmosphere, and living things. Volcanoes released CO2 into the atmosphere, but this was balanced by weathering processes that locked carbon into rocks, and by plant growth that converted atmospheric CO2 into biomass. The residence time of carbon in different reservoirs varied enormously, from years in the atmosphere to millions of years in rock formations. Then everything changed, and humanity became a geological force. In just 2.5 centuries, a geological instant, human activities have released more carbon dioxide into the atmosphere than all the volcanoes in Earth's history combined. We have taken carbon that was safely sequestered in underground deposits, locked away for millions of years, and injected it directly into the air we breathe and the ocean that covers most of our planet's surface. We have accelerated a process that normally takes millions of years and compressed it into the span of just a few human lifetimes. The numbers tell a staggering story that reveals the magnitude of human impact on planetary systems. In 1750, atmospheric carbon dioxide levels stood at about 280 parts per million, a concentration that had remained relatively stable throughout the development of human civilization. By 1900, after a century and a half of coal-powered industrialization, they had risen to 295 parts per million, an increase that seemed modest but represented the beginning of unprecedented change. But the real acceleration came after World War II, during what historians call the Great Acceleration, a period when human impact on Earth systems increased exponentially. The post-war economic boom, fueled by cheap oil and natural gas, powered unprecedented growth in industry, transportation, and consumption. By 2000, atmospheric carbon dioxide had reached 370 parts per million. Today, it exceeds 420 parts per million and continues to rise by more than 2 parts per million every year. To put this in perspective, humans are now pumping approximately 36 billion tons of carbon dioxide into the atmosphere annually, equivalent to the weight of 72 million blue whales released into the air every single year. This is equivalent to the carbon content of a forest covering an area the size of India being burned and released into the atmosphere annually. We have increased the concentration of this heat-trapping gas by more than 50% above pre-industrial levels, and the rate of increase is still accelerating. The scale becomes even more staggering when we consider cumulative emissions. Since the Industrial Revolution began, humanity has released over 1.5 trillion tons of CO2 into the atmosphere. This represents the carbon content of entire ecosystems, forests that took millions of years to grow, compressed into fossil fuels over geological time, then released in mere decades. But carbon dioxide is not the only greenhouse gas whose concentration has soared due to human activities. Methane, a molecule that is more than 25 times more potent than carbon dioxide at trapping heat over a 100-year time frame, has increased by 160% since pre-industrial times. This invisible gas has multiple human sources. Rice paddies flooded for cultivation release methane through bacterial decomposition. The digestive systems of 1.1 billion cattle and other ruminants produce methane through fermentation. Landfills generate methane as organic waste decomposes, and natural gas production releases methane through leaks and intentional venting. Much of this increase comes from agriculture, particularly rice cultivation that feeds half the world's population, and livestock farming that has expanded to meet growing global demand for meat and dairy products. A single cow can produce 220 pounds of methane per year, making livestock agriculture responsible for about 14.5% of global greenhouse gas emissions. The expansion of rice cultivation to feed growing populations has created millions of acres of flooded fields that serve as methane factories, releasing this potent greenhouse gas into the atmosphere. Oil and gas production has also become a major source of methane emissions, as drilling has expanded into previously inaccessible formations. Hydraulic fracturing, or fracking, has unlocked vast reserves of natural gas, but has also led to increased methane leakage throughout the production and distribution system. Studies suggest that methane leakage rates may be high enough to offset some of the climate benefits of switching from coal to natural gas for electricity generation. Nitrous oxide, nearly 300 times more potent than carbon dioxide at trapping heat, has increased by 20% since pre-industrial times, primarily due to the use of nitrogen fertilizers in agriculture. The Haber-Bosch process, developed in the early 20th century to produce ammonia for fertilizers, now consumes about 2% of global energy production and has enabled the population growth that feeds over 7 billion people. However, much of the nitrogen applied to fields is not absorbed by plants and instead is converted by soil bacteria into nitrous oxide. Industrial processes contribute additional greenhouse gases, including fluorinated compounds that are thousands of times more potent than CO2. These synthetic gases, used in refrigeration, air conditioning, and industrial applications, have atmospheric lifetimes measured in decades to centuries. While present in smaller quantities, their extreme potency makes them significant contributors to climate change. The scale of human impact extends far beyond greenhouse gas emissions into every aspect of Earth systems. We have transformed nearly half of the Earth's ice-free land surface, converting forests, grasslands, and wetlands into cities, farms, and industrial sites. This transformation has occurred with breathtaking speed. More land was converted to agriculture in the 30 years after 1950 than in the 150 years between 1700 and 1850. Urbanization has accelerated even more rapidly, with the global urban population growing from 746 million in 1950 to over 4.2 billion today. Cities now cover less than 3% of Earth's land surface, but house more than half of humanity, creating unprecedented concentrations of people, energy consumption, and waste production. The growth of megacities, urban areas with populations exceeding 10 million, represents a completely new phenomenon in human history. We have altered the flow of more than half of the world's rivers through dams, diversions, and water extraction. Over 70,000 large dams now regulate river flows around the world, providing hydroelectric power, irrigation water, and flood control, but also fragmenting river ecosystems and altering sediment transport to coastal areas. The Colorado River in the American Southwest, once powerful enough to carve the Grand Canyon, now rarely reaches the sea due to water extraction for cities and agriculture. Groundwater extraction has accelerated dramatically as surface water sources have become insufficient to meet growing demand. We have extracted groundwater faster than it can be replenished in many regions, lowering water tables by hundreds of feet and causing land to subside in areas from California's Central Valley to Mexico City to Jakarta. Some aquifers that took thousands of years to fill are being drained in decades, representing an irreversible loss of water resources. Our species now appropriates approximately 25% of the planet's total biological productivity, the energy that plants capture from sunlight and convert into food and materials. This represents an unprecedented domination of planetary resources by a single species. We have become the dominant force shaping the evolution of other species, both through direct hunting and habitat destruction, and through the inadvertent introduction of invasive species to new environments. We have created entirely new ecosystems in our cities, while driving others to extinction through our activities. Urban environments now support unique assemblages of plants and animals adapted to human-dominated landscapes, while wilderness areas shrink and fragment under pressure from development, agriculture, and resource extraction. The transformation has been so profound and rapid that scientists have proposed that we have entered a new geological epoch, the Anthropocene, defined by the dominant influence of human activities on the planet's systems. This represents only the second time in Earth's history that a single species has fundamentally altered planetary systems, the first being cyanobacteria, which produced oxygen and triggered the Great Oxidation Event 2.4 billion years ago. Evidence of human impact can now be found in rock layers around the world, creating what geologists call technofossils, artifacts that will persist in the geological record long after our civilization has ended. These include elevated levels of carbon dioxide and other greenhouse gases trapped in ice cores from Greenland and Antarctica, providing a precise record of atmospheric changes since the Industrial Revolution began. Microscopic particles of plastic can be found in sediments from the deepest ocean trenches to remote mountain lakes, creating a distinctive marker of the plastic age that began in the 1950s. Elevated levels of radioactivity from nuclear weapons testing have been deposited in soils and sediments worldwide, marking the beginning of the nuclear age in 1945. The fossils of species driven to extinction by human activities provide another marker, while the bones of domestic animals that now vastly outnumber wild mammals by weight create a distinctive signature in the fossil record. Perhaps most remarkably, this transformation has occurred within the lifetime of people still living today. A person born in 1950 has witnessed atmospheric carbon dioxide levels rise by more than 100 parts per million, a change that would normally take hundreds of thousands of years in the natural world. They have seen the global human population more than triple, from 2.5 billion to over 8 billion people, representing the most rapid population growth in human history. They have witnessed the construction of more than 70,000 large dams that have fundamentally altered river systems around the world. They have seen the paving of millions of miles of roads that fragment landscapes and create barriers to wildlife migration. They have watched as humans launched thousands of satellites into orbit around Earth, creating an artificial constellation of objects that can be seen from the ground with the naked eye. This generation has witnessed the extinction of countless species, while also seeing the development of technologies that could help reverse some human impacts. They have seen the last populations of many large mammals, while also witnessing the beginning of conservation efforts that have brought some species back from the brink of extinction. This acceleration of human impact has created what scientists call Earth system science, the study of how human activities interact with the planet's natural systems. What they have discovered is both sobering and urgent. Earth's climate system has remained remarkably stable for the past 10,000 years, during a geological period called the Holocene that provided the predictable conditions allowing human civilization to develop agriculture, build cities, and create complex societies. This stability was the foundation of human civilization. Reliable seasonal patterns allowed the development of agriculture in regions like the Fertile Crescent, the Indus Valley, and ancient China. Stable sea levels enabled the establishment of coastal cities and ports that became centers of trade and culture. Predictable climate patterns allowed human societies to plan for the future, building monuments and institutions designed to last for generations. But that stability is ending as human activities push Earth systems beyond their natural range of variability. The massive injection of greenhouse gases into the atmosphere is pushing Earth's climate system into uncharted territory, not seen for millions of years. The planet is now absorbing more energy from the sun than it radiates back to space, creating an energy imbalance that is warming the atmosphere, oceans, and land surface. This warming is triggering a cascade of changes throughout the Earth system that are accelerating and amplifying each other. Melting ice sheets reduce the planet's ability to reflect sunlight, leading to more warming. Thawing permafrost releases stored carbon, adding to greenhouse gas concentrations. Changing precipitation patterns stress forests, making them more vulnerable to fires that release more carbon. These changes are altering the distribution of plants and animals around the world, forcing species to migrate toward the poles or to higher elevations in search of suitable climate conditions. Many species cannot migrate fast enough to keep pace with climate change, leading to local extinctions and ecosystem disruption. The transformation that began in the coal fields of 18th century Britain has become a planetary phenomenon that touches every aspect of Earth's systems. Every breath of air we take contains molecules that bear the chemical signature of fossil fuel combustion. Every drop of rain that falls carries trace amounts of human-produced chemicals. Every ecosystem on Earth now bears the influence of human activities, from the deepest ocean trenches to the highest mountains. We have become a geological force comparable to volcanoes, earthquakes, and ice ages. But unlike these natural forces, we have the power to choose what kind of planet we leave for future generations. We have the knowledge to understand our impact and the technology to change course, if we choose to use it. The question is no longer whether human activities are changing the planet. The evidence is overwhelming and undeniable. The question is what kind of changes we are willing to accept and what we are prepared to do to influence the trajectory we are on. The story of the human footprint is still being written, and we are the authors of its next chapter. Every day we delay action. We commit future generations to living with more severe climate impacts. Every year we continue on our current path. We make it more difficult and expensive to achieve the transformations needed to prevent catastrophic changes. But we still have time to change course, if we act quickly and decisively. Chapter 3. Climate in Crisis. The first signs were subtle. A degree warmer here, a storm slightly more intense there, ice forming a few days later than usual. For decades, these changes fell within the range of natural variability that people expected from weather and seasons. But gradually, inexorably, the signals began to emerge from the noise of natural fluctuations, revealing a pattern that would fundamentally alter life on Earth. The climate system, that vast, interconnected web of atmosphere, oceans, ice, and land that governs Earth's weather patterns, is entering a phase of instability not seen for millions of years. The engine of life on our planet, the system that has provided the stable conditions allowing human civilization to flourish, is being pushed beyond its limits by the rapid accumulation of greenhouse gases in the atmosphere. Global average temperatures have already risen by approximately 1.2 degrees Celsius above pre-industrial levels. While this might seem like a small change, it represents an enormous shift in the energy balance of the planet. The amount of extra heat being trapped by greenhouse gases is equivalent to exploding 400,000 Hiroshima-sized atomic bombs every day. This additional energy is driving changes throughout the climate system at a rate that is unprecedented in human history. To understand the magnitude of this change, consider that the difference between today's climate and the last ice age, when massive ice sheets covered much of North America and Europe, was only about 6 degrees Celsius. We have already warmed the planet by 1/5 of that amount in just 150 years, and the rate of change is accelerating. Each of the last 4 decades has been successively the warmest on record, with 19 of the 20 warmest years occurring since 2000. The warming is not evenly distributed across the planet, creating a complex pattern of regional changes that are disrupting weather systems and ecological relationships everywhere. The Arctic is warming at twice the global average, a phenomenon known as Arctic amplification. This occurs because, as white sea ice melts and reveals dark ocean water beneath, more sunlight is absorbed rather than reflected back to space, creating a feedback loop that accelerates warming even further. The consequences of Arctic warming ripple throughout the global climate system like stones thrown into a pond. The temperature difference between the Arctic and lower latitudes drives the jet stream, the river of fast-moving air that circles the planet and steers weather systems. As this temperature difference decreases, the jet stream becomes weaker and more erratic, causing weather patterns to move more slowly and persist for longer periods. This leads to stuck weather patterns that can bring prolonged heat waves, extended droughts, or persistent storms that dump unprecedented amounts of rain in small areas. The polar vortex events that have brought Arctic cold to southern latitudes, the heat domes that have shattered temperature records, and the atmospheric rivers that cause flooding are all symptoms of a destabilized jet stream. The Greenland ice sheet, a frozen reservoir containing enough water to raise global sea levels by 7 meters, is melting at an accelerating pace that has shocked even climate scientists. In the summer of 2019, Greenland lost 532 billion tons of ice, enough to raise global sea levels by 1.5 millimeters in just 2 months. To put this in perspective, this single summer's ice loss contained enough water to supply every person on Earth with 20 gallons per day for an entire year. What once was considered an exceptional year has become the norm, with massive melting events now occurring regularly. Melt ponds, lakes of water that form on the ice surface during summer, are appearing at elevations and latitudes where they have never been observed before. These dark pools absorb more sunlight than white ice, accelerating melting through another feedback loop. Scientists have discovered that warm ocean water is penetrating beneath the edges of the Greenland ice sheet, creating cavities that undermine the ice from below. Glaciers that once moved at the stately pace of meters per year are now retreating at rates measured in kilometers per year. The massive Jakobshavn Glacier, which produces about 10% of Greenland's icebergs, has doubled its flow speed in recent decades. Antarctica, long considered stable due to its extreme cold, is also showing signs of dramatic change that could reshape global coastlines. The West Antarctic ice sheet, which contains enough ice to raise sea levels by 4 meters, appears to be in irreversible decline according to multiple studies. Warm ocean water, driven by changing wind patterns, is infiltrating beneath the ice sheet, causing massive glaciers to thin and retreat. The Pine Island and Thwaites glaciers, sometimes called the weak underbelly of West Antarctica, are retreating so rapidly that they could trigger the collapse of the entire West Antarctic ice sheet within centuries. The Thwaites Glacier alone, roughly the size of Florida, acts as a cork holding back a much larger volume of ice. If it were to collapse completely, it could destabilize enough ice to raise sea levels by several meters. Even East Antarctica, long considered the most stable part of the continent, is showing signs of change. Satellite measurements reveal that some coastal glaciers are thinning, while increased snowfall in the interior was once thought to balance ice losses. However, recent studies suggest that even the East Antarctic ice sheet may be more vulnerable to warming than previously believed. Mountain glaciers around the world tell the same story of accelerating change, serving as visible indicators of a warming world. From the Swiss Alps to the Himalayas, from the Andes to the Rocky Mountains, glaciers that have existed for thousands of years are disappearing within decades. The glaciers of Glacier National Park in Montana, once numbering 150, have dwindled to fewer than 30. Many of the remaining glaciers are so small that they may disappear within decades. The iconic snows of Mount Kilimanjaro have shrunk by more than 80% since 1912, transforming the mountain from a snow-capped symbol of Africa to a bare volcanic peak. Similar losses are occurring on mountains around the world, from Mount Kenya to the Peruvian Andes, where entire communities depend on glacier-fed rivers for their water supply. In the Himalayas, the third pole that stores more ice than anywhere except Antarctica and Greenland, glaciers are retreating at rates that threaten water security for over 1 billion people. The Gangotri Glacier, source of the sacred Ganges River, is retreating at a rate of 22 meters per year. As these glaciers disappear, the rivers they feed will become more erratic, with devastating floods during monsoon season followed by severe droughts. These changes in ice cover are already contributing to rising sea levels, which have accelerated from an average rate of 1.7 millimeters per year in the 20th century to more than 3 millimeters per year today. While this may seem small, the cumulative effect is transforming coastlines around the world. Since 1993, when precise satellite measurements began, sea levels have risen by more than 10 centimeters, with the rate continuing to accelerate. Coastal communities around the world are experiencing more frequent flooding during high tides and storms, a phenomenon known as sunny day flooding or nuisance flooding. Cities from Miami to Norfolk to Bangkok regularly experience flooding even during minor storms or exceptionally high tides. Some island nations, including Tuvalu, Kiribati, and the Marshall Islands, are planning for complete evacuation and relocation of their populations within decades. The warming atmosphere is also fundamentally altering precipitation patterns around the world in ways that are disrupting agriculture, water supplies, and human settlements. A warmer atmosphere can hold more moisture, about 7% more for every degree of warming, leading to more intense rainfall and snowfall events when storms do occur. At the same time, the regions between storm tracks are experiencing longer and more severe droughts as evaporation rates increase and weather patterns become more persistent. This creates a world of increasingly extreme precipitation, Either too much water in the wrong place at the wrong time, or too little water when and where it's needed. The result is more frequent and severe flooding alternating with more intense and prolonged droughts, often in the same regions but at different times. Heat waves are becoming more frequent, more intense, and longer lasting around the world. The European heat wave of 2003, which killed over 70,000 people, would have been virtually impossible without human-induced climate change, according to multiple attribution studies. The event was so extreme that it was considered a once-in-500-year occurrence, yet similar heat waves now occur regularly. Similar extreme heat events are now occurring regularly around the world, with temperatures reaching levels that are literally deadly for human beings. In 2021, the Pacific Northwest experienced temperatures exceeding 115 degrees F, 46 degrees C, shattering previous records by unprecedented margins and killing hundreds of people. The small town of Lytton, British Columbia, reached 121 degrees F before being completely destroyed by wildfire the next day. These extreme temperatures are pushing the limits of human physiological adaptation. The human body maintains its core temperature through sweating, but this cooling mechanism fails when the combination of heat and humidity, measured as wet bulb temperature, exceeds about 95 degrees F, 35 degrees C. At this point, even healthy people sitting in the shade with unlimited water will overheat and die within hours. While sustained wet bulb temperatures of 35 degrees C have not yet been observed, several locations have approached this threshold during extreme heat events. Parts of India, Pakistan, and the Persian Gulf have experienced wet bulb temperatures above 33 degrees C, and climate models suggest that deadly heat will become more common as warming continues. Wildfire seasons are becoming longer and more destructive as rising temperatures dry out vegetation and create conditions conducive to large, fast-moving fires. The area burned by wildfires in the western United States has doubled since the 1980s, and fires are burning at higher elevations and latitudes than ever before. What were once considered fire seasons are now year-round concerns in many regions. Australia's 2019-2020 fire season, dubbed the Black Summer, burned an area larger than Florida, killing billions of animals and destroying thousands of homes. The fires were so intense that they created their own weather systems, generating lightning that sparked additional fires and producing smoke plumes that circumnavigated the globe. These megafires are creating their own feedback loops with climate change. When forests burn, they release the carbon they have stored for decades or centuries, adding to greenhouse gas concentrations. Burned areas are also darker than living forests, absorbing more sunlight and contributing to local warming. Some burned forests are not regenerating, transforming from carbon sinks to carbon sources permanently. Ocean temperatures are rising as the vast bodies of water that cover 71% of Earth's surface absorb more than 90% of the excess heat trapped by greenhouse gases. The oceans act as a massive thermal buffer for the planet, but this comes at a cost. Marine ecosystems are being stressed by temperatures that exceed their tolerance ranges. Marine heat waves, periods of exceptionally warm ocean temperatures, are becoming 5 times more frequent than they were in the 1980s and lasting much longer. These extreme events are devastating marine ecosystems, causing mass mortality events, disrupting food webs and forcing species to migrate to cooler waters. The most visible impact of marine heat waves is coral bleaching, a stress response where corals expel the algae that provide them with food and color. When water temperatures rise just 1-2 degrees Celsius above normal for several weeks, corals bleach and can die if conditions don't improve quickly. The Great Barrier Reef has experienced 3 mass bleaching events in just 5 years, with half of its shallow water corals dying since 2016. The chemistry of the oceans is also changing as they absorb about 30% of the carbon dioxide emitted by human activities. This is making seawater more acidic, a process known as ocean acidification, or the other CO2 problem. The pH of ocean surface waters has dropped by 0.1 units since pre-industrial times, representing a 30% increase in acidity. This change is making it more difficult for shell-forming organisms like corals, mollusks, and certain plankton to build and maintain their calcium carbonate structures. Ocean acidification is already affecting oyster farms in the Pacific Northwest, where young oysters sometimes cannot form shells in water that has become too acidic. The impact extends throughout marine food webs, as many of the tiny planktonic organisms at the base of the ocean food chain have shells made of calcium carbonate. As these organisms struggle to survive in more acidic conditions, the effects cascade upward through the entire marine ecosystem. Storm systems are becoming more intense as they draw energy from warmer ocean waters. While the total number of hurricanes and typhoons may not be increasing dramatically, the proportion of the most powerful storms, Category 4 and 5 hurricanes, is growing. These storms are also producing more rainfall, with some hurricanes dropping over 50 inches of rain in a matter of days. Hurricanes are also maintaining their intensity longer as they move inland, causing more extensive flooding and damage far from the coast. Hurricane Harvey, which devastated Houston in 2017, stalled over the city for days, dumping more than 60 inches of rain in some areas. The storm produced so much rain that it temporarily lowered sea levels in the Gulf of Mexico by several inches. The monsoon systems that bring life-giving rains to billions of people across Asia, Africa, and the Americas are becoming increasingly erratic. These seasonal wind patterns, driven by temperature differences between continents and oceans, are being disrupted by changing climate patterns. Some regions are experiencing more intense monsoons that cause devastating floods, while others face weakening monsoons that lead to severe droughts. The timing of these seasonal rains is also shifting, disrupting agricultural systems that have relied on predictable seasonal patterns for thousands of years. In India, the monsoon that provides 80% of the country's annual rainfall is becoming more erratic, with longer dry spells followed by intense downpours that cause flooding. Farmers who have planned their crops around monsoon timing for generations are finding their traditional knowledge no longer reliable. Perhaps most concerning of all, scientists have identified several tipping points in the climate system, thresholds beyond which changes become self-reinforcing and potentially irreversible. These tipping points represent points of no return, where natural feedback loops take over and drive changes even if human emissions were to stop completely. The collapse of the West Antarctic ice sheet, the shutdown of Atlantic Ocean circulation, the dieback of the Amazon rainforest, and the release of methane from thawing permafrost are all examples of potential tipping points that could trigger cascading changes throughout the Earth system. Recent research suggests that some of these tipping points may be reached at lower levels of warming than previously thought. Some of these tipping points may already be in motion. The Amazon rainforest, which has served as a carbon sink for decades by absorbing more CO2 than it releases, may be transitioning to become a source of carbon dioxide as deforestation and climate change combine to stress the ecosystem beyond its limits. Large sections of the Amazon are now experiencing longer dry seasons that make trees vulnerable to fire and disease. When forests burn or die, they release the carbon they have stored for decades or centuries. Scientists estimate that the Amazon could reach a tipping point where it transforms from rainforest to savanna within decades, releasing billions of tons of stored carbon and eliminating one of the world's most important carbon sinks. The permafrost of the Arctic tundra, which contains twice as much carbon as the entire atmosphere, is beginning to thaw at depths and rates not seen for thousands of years. As permanently frozen ground melts, it releases methane and carbon dioxide that have been locked away for millennia. Permafrost thaw creates its own feedback loop. As greenhouse gases are released, they contribute to further warming, which causes more permafrost to thaw. The process is accelerating as temperatures rise, with some areas of Alaska and Siberia experiencing ground temperatures that are rising by several degrees per decade. The Atlantic meridional overturning circulation, the system of ocean currents that includes the Gulf Stream, may be slowing due to the input of fresh water from melting ice sheets. This circulation system transports warm water northward and cold water southward, helping to moderate global temperatures. If it were to shut down, it could cause rapid cooling in Europe while accelerating warming in other regions. The climate crisis is not a distant threat. It is happening now in real time all around us. Every fraction of a degree of additional warming brings more severe consequences. Every year of delay in reducing greenhouse gas emissions commits the planet to decades or centuries of additional change. The climate system has tremendous inertia, meaning that even if emissions were stopped tomorrow, temperatures would continue to rise for decades due to greenhouse gases already in the atmosphere. The warming we have experienced so far is the result of emissions from decades past. The changes our children will experience are being determined by the emissions we produce today, and the changes our grandchildren will inherit depend on the choices we make in the next few years. This is the new reality we must confront, a planet where the stable climate that allowed human civilization to develop is giving way to a more chaotic, unpredictable, and potentially hostile environment. The question is not whether the climate will continue to change. It will. The question is how much change we are willing to accept and how quickly we can act to limit the most catastrophic outcomes. The climate system that has been the foundation of human civilization is in crisis. But understanding the nature of this crisis is the first step toward addressing it. We still have a narrow window of time to prevent the most catastrophic changes, but that window is closing rapidly. Every day we delay action. Every year we continue on our current path. We commit future generations to living with more severe climate impacts. But we also still have the power to change course, to bend the curve of emissions downward, and to build a more resilient world. Time is running out, but it has not yet run out. The next chapter in the story of Earth's climate is still being written, and we still have the power to influence how it ends. The question is whether we will use that power wisely, and whether we will act quickly enough to make a difference. The climate crisis is the defining challenge of our time. How we respond will determine not just the future of human civilization, but the fate of countless other species and ecosystems that share our planet. The choice is ours, but we must make it soon. Chapter 4. Ecosystems at the breaking point. Across the planet, the intricate web of life that has evolved over millions of years is unraveling at a pace that scientists describe as the sixth mass extinction. From the depths of the oceans to the canopies of tropical forests, from Arctic tundra to coral reefs, ecosystems that once seemed infinite in their resilience are reaching their breaking points under the mounting pressures of human activities and climate change. The statistics are staggering and heartbreaking. Since 1970, populations of wild vertebrate species have declined by an average of 69%. In tropical regions, the decline reaches 94%. Every day, between 150 and 200 species go extinct, a rate that is 1,000 to 10,000 times higher than the natural background rate of extinction. We are living through what biologists call the Anthropocene definition, the human-caused loss of animals from ecosystems around the world. The Amazon rainforest, often called the lungs of the earth, exemplifies the crisis facing ecosystems worldwide. This vast green cathedral, which covers an area larger than the continental United States and contains more biodiversity than anywhere else on Earth, is being destroyed at a rate of nearly 10,000 square kilometers per year. What took millions of years to evolve is being erased in decades through deforestation, cattle ranching, and agricultural expansion. But the threats to the Amazon extend beyond direct deforestation. Climate change is pushing the forest beyond its tolerance limits, creating longer and more severe dry seasons that make trees vulnerable to fire and disease. Scientists estimate that 20% of the Amazon has already been destroyed, and another 20% is severely degraded. Research suggests that when 25% of the forest is lost, the entire ecosystem could collapse, transforming from a lush rainforest into a dry savanna and releasing billions of tons of stored carbon into the atmosphere. The destruction of forests is a global phenomenon. Indonesia's palm oil plantations have consumed vast areas of tropical forest, destroying habitat for orangutans, tigers, and countless other species. The boreal forests of Canada and Russia, which contain more carbon than tropical forests, are being harvested at rates that exceed their ability to regenerate. Temperate forests in Europe and North America face new threats from invasive pests and diseases that thrive in warming climates. As forests disappear, so do the countless species that call them home. Forest elephants in Africa have declined by 75% in just 15 years due to poaching and habitat loss. Orangutan populations in Borneo and Sumatra have fallen by 50% since 1999. The great apes, our closest relatives in the animal kingdom, face extinction in the wild within our lifetimes unless current trends are reversed. In the oceans, coral reefs, often called the rainforests of the sea, are experiencing unprecedented devastation. These underwater cities of life, which support 25% of all marine species despite covering less than 1% of the ocean floor, are being destroyed by warming waters, ocean acidification, and pollution. When water temperatures rise just 1-2 degrees Celsius above normal, corals expel the algae that give them color and provide their food, turning white in a process called bleaching. The Great Barrier Reef, the world's largest coral reef system and one of the 7 natural wonders of the world, has experienced 3 mass bleaching events in just 5 years. Half of its shallow water corals have died since 2016. Similar devastation is occurring on reefs throughout the tropics, from the Caribbean to Southeast Asia. Scientists estimate that 50% of the world's coral reefs have been lost, and without dramatic action to reduce greenhouse gas emissions, the remainder could be gone by 2050. The collapse of coral reefs has cascading effects throughout marine ecosystems. Fish populations that depend on reefs for shelter and food are declining rapidly. The tourism and fishing industries that support millions of people are collapsing along with the reefs. Coastal communities that rely on reefs for protection from storms and waves are becoming more vulnerable to sea level rise and extreme weather. Ocean ecosystems far from coral reefs are also in crisis. Overfishing has reduced populations of large predatory fish by 90% since pre-industrial times. Bluefin tuna, once abundant in the Atlantic and Pacific, have been fished to the brink of extinction. The collapse of cod fisheries in the North Atlantic in the 1990 put thousands of people out of work and demonstrated that even seemingly inexhaustible ocean resources have limits. Marine ecosystems face additional threats from pollution, particularly plastic waste. Every minute, the equivalent of a garbage truck full of plastic enters the ocean. This plastic breaks down into microparticles that are consumed by marine life, from tiny plankton to great whales. Scientists have found plastic in the stomachs of deep-sea creatures living in ocean trenches and in the tissues of fish sold in markets around the world. Dead zones, areas of ocean water with so little oxygen that most marine life cannot survive, are expanding rapidly due to agricultural runoff rich in nitrogen and phosphorus. These nutrients fuel explosive growth of algae, which consume oxygen as they decompose, creating vast underwater deserts where once productive fisheries existed. The Gulf of Mexico dead zone now covers an area the size of Massachusetts and continues to grow each year. On land, grassland ecosystems that once covered vast areas of the planet have been reduced to fragments. The North American prairie, which once extended from Canada to Texas and supported enormous herds of bison, has been reduced by 99%. Only small patches remain, isolated in a sea of agricultural fields. The destruction of grasslands has eliminated habitat for countless species and released massive amounts of stored carbon into the atmosphere. Arctic ecosystems are experiencing some of the most rapid changes on Earth. As temperatures rise and sea ice melts, polar bears struggle to find food and are being forced to travel greater distances to hunt. Walruses, which depend on sea ice as platforms for resting and accessing food, are crowding onto beaches in unprecedented numbers. Arctic char and other cold water fish are being pushed northward as waters warm, but they are running out of suitable habitat as they approach the limits of the Arctic Ocean. The tundra, a vast ecosystem that has remained frozen for thousands of years, is beginning to thaw as temperatures rise. This thawing releases methane and carbon dioxide into the atmosphere, accelerating climate change. It also destabilizes the ground, damaging infrastructure, and altering the hydrology of entire regions. Plants and animals adapted to the extreme cold of the Arctic are finding their world literally melting beneath them. Wetlands, which provide crucial services including flood control, water purification, and carbon storage, have been particularly hard hit by human activities. Half of the world's wetlands have been destroyed, mostly for agriculture and urban development. The remaining wetlands face new threats from sea level rise, changing precipitation patterns, and invasive species. The loss of wetlands has devastating consequences for migratory birds, which depend on these ecosystems as stopover points during their long journeys. Shorebird populations have declined by 70% since 1973, and many species face extinction as their critical habitat disappears. The loss of wetlands also increases flood risk for human communities and reduces the natural systems that filter pollutants from water. Desert ecosystems, despite their harsh conditions, support specially adapted communities of plants and animals. But even these resilient ecosystems are under threat as climate change makes some regions too hot and dry even for desert species. At the same time, human activities are creating new deserts through overgrazing, deforestation, and poor agricultural practices, a process called desertification that affects 1.5 billion people worldwide. Mountain ecosystems face unique challenges as climate change pushes species upslope in search of cooler temperatures. But as species move higher, they eventually run out of mountain, a phenomenon scientists call summit trap. Alpine plants and animals that have lived on mountaintops for thousands of years have nowhere left to go as their habitats warm. The interconnected nature of ecosystems means that the collapse of one can trigger cascading effects throughout others. The decline of bee populations due to pesticide use, habitat loss, and disease threatens the pollination services that are essential for both wild plants and agricultural crops. Without pollinators, many ecosystems would collapse and global food production would be severely impacted. Large predators, which play crucial roles in maintaining ecosystem balance, have been particularly hard hit by human activities. Wolf populations in most of their former range have been eliminated, leading to overgrazing by deer and elk that changes the structure of entire ecosystems. Lion populations in Africa have declined by 75% in just 50 years. Tigers, leopards, jaguars, and other big cats face extinction as their habitat is destroyed and fragmented. The loss of these keystone species, animals that have disproportionate impacts on their ecosystems, can cause entire ecological communities to collapse. When large predators disappear, prey species can become overabundant and overconsume vegetation. When beavers are eliminated from watersheds, the dams they build no longer regulate water flow, leading to changes in stream ecology that ripple throughout the ecosystem. Perhaps most tragically, many species are disappearing before scientists have even had a chance to study them. In tropical forests, which contain the highest diversity of life on Earth, new species are discovered regularly, but they are going extinct faster than they can be cataloged. We are losing libraries of genetic information, potential sources of new medicines, and irreplaceable components of the web of life. The crisis facing ecosystems around the world is not just an environmental tragedy. It is a threat to human survival. Healthy ecosystems provide services that are essential to human well-being. They purify air and water, regulate climate, prevent floods and droughts, pollinate crops, and provide resources for medicine, food, and materials. The economic value of these ecosystem services has been estimated at $125 trillion annually, nearly twice the global GDP. As ecosystems collapse, these services are lost, forcing humans to find technological substitutes that are often more expensive and less effective than natural systems. The cost of replacing ecosystem services with human-made alternatives, where it is even possible, would bankrupt human civilization. The current rate of ecosystem destruction and species extinction is not sustainable. We are undermining the natural systems that support all life on Earth, including our own. The question is not whether we can survive without healthy ecosystems. We cannot. The question is whether we will act quickly enough to prevent the complete collapse of the natural world and the civilization that depends on it. But even in this dark moment, there are glimmers of hope. Conservation efforts have brought some species back from the brink of extinction. Protected areas preserve critical habitats and provide refuges for wildlife. Restoration projects are healing damaged ecosystems and bringing life back to degraded landscapes. The challenge is to scale these efforts up to match the magnitude of the crisis we face. The fate of the world's ecosystems and our own future hangs in the balance. The next few decades will determine whether we can step back from the brink and find a way to live in harmony with the natural world that sustains us, or whether we will continue down the path toward ecological collapse. The choice is ours, but time is running out. Chapter 5. The Age of Contamination. We live in an age where human-made substances have penetrated every corner of the planet, from the deepest ocean trenches to the highest mountain peaks, from the Arctic ice to the cells of unborn children. The signature of human industrial activity can be found in the tissues of whales swimming in the most remote seas, in the snow falling on pristine wilderness areas, and in the air above the most isolated islands on Earth. We have created a new geological epoch defined not just by climate change, but by the ubiquitous presence of human-made pollutants. The scale of contamination is staggering. Every year, human activities release more than 140 billion tons of pollutants into the environment, a mass equivalent to 25,000 Great Pyramids of Giza. This includes 36 billion tons of carbon dioxide, 11 billion tons of particulate matter, and countless tons of chemical compounds that did not exist on Earth before human beings learned to synthesize them in laboratories and factories. Perhaps no pollutant better symbolizes the age of contamination than plastic. Since mass production began in the 1950s, humans have created more than 9 billion tons of plastic, enough to cover the entire continental United States in a layer nearly 2 inches thick. Of this enormous quantity, less than 10% has been recycled. Most of the rest has ended up in landfills, incinerators, or scattered across the natural environment. In the world's oceans, plastic pollution has reached crisis levels. An estimated 8 million tons of plastic waste enters marine environments every year, equivalent to dumping a garbage truck full of plastic into the ocean every minute. This plastic doesn't disappear. It breaks down into smaller and smaller fragments that persist in the environment for hundreds of years. Microplastics, particles smaller than 5 millimeters, are now found throughout the marine food web, from tiny plankton to great whales. The Great Pacific Garbage Patch, a swirling mass of plastic debris larger than Texas, has become a symbol of ocean pollution. But this visible accumulation represents only a small fraction of the plastic in the ocean. Most plastic pollution is invisible, consisting of microparticles suspended in the water column or settled on the seafloor. These particles are consumed by marine life, accumulating in tissues and potentially disrupting biological processes. Scientists have found plastic in the most remote corners of the ocean, including the deepest point on Earth, the Challenger Deep in the Mariana Trench. Even in the Arctic, far from major population centers, ice cores contain microplastic particles carried north by ocean currents and atmospheric circulation. Plastic pollution has become so pervasive that it is falling from the sky as precipitation, with microplastic particles detected in rainwater from urban areas to remote mountain ranges. The impact on marine life is devastating. Sea turtles mistake plastic bags for jellyfish and die from intestinal blockages. Seabirds feed plastic fragments to their chicks, filling their stomachs with indigestible material that prevents them from getting proper nutrition. Whales and dolphins become entangled in discarded fishing nets, suffering slow and painful deaths. An estimated 100,000 marine mammals and 1 million seabirds die each year from plastic pollution. But plastic is just one form of chemical contamination affecting the planet. Since World War II, the chemical industry has created more than 140,000 synthetic compounds, most of which did not exist in nature before human beings invented them. Many of these chemicals are released into the environment without adequate testing of their long-term effects on human health or ecological systems. Persistent organic pollutants (POPs) represent some of the most dangerous forms of chemical contamination. These substances, which include pesticides like DDT, industrial chemicals like PCBs, and byproducts of combustion like dioxins, do not break down readily in the environment. Instead, they accumulate in the tissues of living organisms, becoming more concentrated as they move up the food chain. The effects of POPs can be seen in wildlife populations around the world. Bald eagles in North America nearly went extinct in the 1960s due to DDT contamination, which caused their eggshells to thin and break during incubation. Polar bears in the Arctic carry high levels of PCBs in their tissues, despite living thousands of miles from the nearest industrial source. These chemicals can disrupt hormone systems, impair reproduction, and compromise immune function. Air pollution represents another massive form of global contamination. Every year, human activities release billions of tons of pollutants into the atmosphere, including sulfur dioxide, nitrogen oxides, carbon monoxide, and particulate matter. The World Health Organization estimates that 9 out of 10 people worldwide breathe air that exceeds recommended pollution guidelines. Fine particulate matter, consisting of particles less than 2.5 micrometers in diameter, is particularly dangerous because these particles are small enough to penetrate deep into the lungs and enter the bloodstream. Exposure to fine particulate matter is linked to heart disease, stroke, lung cancer, and premature death. The World Health Organization estimates that air pollution kills 7 million people every year, more than AIDS, tuberculosis, and malaria combined. The sources of air pollution are diverse and widespread. Coal-fired power plants release sulfur dioxide and mercury into the atmosphere. Vehicle exhaust contributes nitrogen oxides and carbon monoxide. Industrial processes emit volatile organic compounds and heavy metals. Agricultural activities produce ammonia and methane. Wildfires, increasingly common due to climate change, release massive amounts of particulate matter and toxic gases. In many developing countries, the situation is particularly severe. Cities like Delhi, Beijing, and Lagos regularly experience air pollution levels that are 5 to 10 times higher than World Health Organization guidelines. In these urban areas, the air is often so polluted that it reduces life expectancy by several years. Children growing up in heavily polluted cities show reduced lung development and increased rates of asthma and other respiratory diseases. But air pollution is not confined to urban areas. Atmospheric circulation carries pollutants thousands of miles from their sources, contaminating even the most remote regions of the planet. Mercury emissions from coal-fired power plants in Asia can be detected in fish caught in the Arctic Ocean. Dust storms in the Sahara Desert carry agricultural pesticides from Africa to the Caribbean. Industrial pollutants from China and India have been found in snow samples from Mount Everest. Soil contamination represents another pervasive form of environmental pollution. Industrial activities, mining operations, and agricultural practices have contaminated millions of acres of soil with heavy metals, pesticides, and other toxic substances. Lead contamination from decades of leaded gasoline use persists in soils around the world, particularly in urban areas near busy roads. Agricultural soils face particular challenges from the intensive use of fertilizers and pesticides. Nitrogen fertilizers, while boosting crop yields, can contaminate groundwater with nitrates that are harmful to human health. Excessive nitrogen also contributes to the eutrophication of waterways, creating dead zones where aquatic life cannot survive. Pesticide contamination of soils and water has reached alarming levels in many agricultural regions. Neonicotinoids, a class of insecticides widely used on crops, have been linked to the decline of bee populations and other beneficial insects. These chemicals persist in the environment for months or years, continuing to affect non-target species long after application. The groundwater that supplies drinking water to billions of people is increasingly contaminated with industrial chemicals, agricultural pollutants, and human waste. In many parts of the world, groundwater aquifers that took thousands of years to fill are being polluted faster than they can naturally clean themselves. Once contaminated, groundwater can remain polluted for decades or centuries. Pharmaceutical contamination represents an emerging threat to water quality. Antibiotics, hormones, and other medications pass through sewage treatment plants largely unchanged and enter rivers, lakes, and groundwater. This pharmaceutical pollution can disrupt the hormone systems of fish and other aquatic life, and may contribute to the development of antibiotic-resistant bacteria. Heavy metal contamination from mining and industrial activities has created some of the most severely polluted places on Earth. The Berkeley Pit in Montana, a former copper mine, has filled with water so acidic and contaminated with heavy metals that it kills migrating birds that land on its surface. In China, entire rivers have been turned red or black by industrial pollution, and vast areas of agricultural land have been contaminated with cadmium, lead, and other toxic metals. Electronic waste represents a rapidly growing form of contamination. As smartphones, computers, and other electronic devices become obsolete at an accelerating pace, they create mounting piles of e-waste containing toxic substances like lead, mercury, and cadmium. Much of this e-waste is shipped to developing countries, where it is processed in informal recycling operations that expose workers and communities to dangerous levels of toxic substances. Radioactive contamination, while less widespread than chemical pollution, creates some of the most persistent forms of environmental damage. The Chernobyl disaster in 1986 contaminated vast areas of Ukraine, Belarus, and Russia with radioactive substances that will remain dangerous for thousands of years. The Fukushima disaster in 2011 released radioactive materials into the Pacific Ocean, affecting marine ecosystems and fisheries. Nuclear weapons testing during the Cold War scattered radioactive fallout across the globe, creating a distinct geological marker of human impact on the planet. Indigenous communities in the Marshall Islands, Kazakhstan, and other testing sites continue to suffer from elevated rates of cancer and other health problems decades after the tests ended. Light pollution represents a form of contamination that is often overlooked, but has significant impacts on both human health and wildlife. The glow of artificial lights now illuminates most of the planet's inhabited areas, disrupting natural cycles of light and darkness that have existed for billions of years. This light pollution affects the migration patterns of birds, the reproductive cycles of sea turtles, and the behavior of countless nocturnal species. For humans, exposure to artificial light at night disrupts circadian rhythms and may contribute to sleep disorders, depression, and increased risk of certain cancers. Many people living in urban areas have never seen the Milky Way due to light pollution, representing a profound disconnection from the natural world. Noise pollution is another pervasive form of contamination that affects both human health and wildlife. Traffic noise, aircraft noise, and industrial noise create a constant din that can cause stress, hearing loss, and cardiovascular problems in humans. For wildlife, noise pollution can interfere with communication, navigation, and feeding behaviors. In the world's oceans, noise pollution from shipping, military sonar, and offshore construction has reached levels that interfere with the communication and navigation systems of whales, dolphins, and other marine mammals. Some species have been forced to alter their behavior or abandon traditional feeding and breeding areas due to noise pollution. The cumulative impact of all forms of contamination is creating a toxic legacy that will persist for generations. Children today are born with dozens of industrial chemicals in their blood, including substances that have been banned for decades but persist in the environment. The breast milk of mothers around the world contains measurable levels of pesticides, flame retardants, and other synthetic chemicals. This chemical contamination may be affecting human health in ways that are only beginning to be understood. Rates of certain cancers, developmental disorders, and reproductive problems have increased in recent decades, potentially linked to exposure to environmental toxins. The economic costs of pollution-related health problems run into hundreds of billions of dollars annually. The contamination of our planet represents one of the great moral challenges of our time. We have created a world where no place remains untouched by human-made pollutants, where children are exposed to toxic chemicals from the moment of conception, where the natural systems that sustain life are being poisoned by the byproducts of human industrial activity. But recognition of this crisis is also driving innovation and change. Clean technologies are being developed to reduce pollution at its source. Bioremediation techniques use living organisms to clean up contaminated sites. International agreements are beginning to address the most dangerous forms of pollution, such as persistent organic pollutants and mercury emissions. The age of contamination need not be permanent. With concerted effort, we can reduce pollution, clean up contaminated sites, and develop cleaner ways of meeting human needs. But this will require fundamental changes in how we produce and consume goods, how we generate energy, and how we treat the waste products of human civilization. The planet that we leave to future generations will be determined by the choices we make today about pollution and contamination. We can continue down the current path toward ever greater contamination of our air, water, and soil, or we can choose to create a cleaner, healthier world. The technology and knowledge exist to make this choice. What remains to be seen is whether we have the will to act on what we know. Chapter 6. The Human Impact. Climate change is not an abstract future threat. It is a present reality that is already reshaping human civilization in profound and often devastating ways. From the megacities of Asia to the small island nations of the Pacific, from the agricultural heartlands of Africa to the coastal communities of North America, the impacts of our changing climate are being felt by billions of people around the world. The statistics tell a sobering story. Climate-related disasters now affect more than 200 million people every year, a number that continues to rise as extreme weather events become more frequent and intense. Since 2000, climate and weather-related disasters have caused economic losses exceeding $3 trillion globally, with developing countries bearing a disproportionate share of both the human and economic costs. Water scarcity represents one of the most immediate and widespread impacts of climate change on human communities. As temperatures rise and precipitation patterns shift, many regions that have sustained human civilization for millennia are experiencing unprecedented droughts. The Day Zero crisis in Cape Town, South Africa, where the city nearly ran out of water entirely, provided a glimpse of what millions more people may face in the coming decades. Currently, more than 2 billion people lack access to safely managed drinking water, and climate change is making this crisis worse. In the Middle East, North Africa, and parts of South Asia, aquifers that have sustained civilizations for thousands of years are being depleted faster than they can recharge. The Jordan River, once a mighty waterway that sustained ancient civilizations, now barely reaches the Dead Sea due to overextraction and reduced rainfall. In India, more than 600 million people face acute water shortages as monsoon patterns become increasingly unpredictable and groundwater levels drop precipitously. The city of Chennai, home to 7 million people, ran completely out of groundwater in 2019, forcing residents to depend on water delivered by train from hundreds of miles away. Similar crises are unfolding across the global south, where climate change is exacerbating existing water stress. Agricultural systems, which form the foundation of human food security, are under unprecedented strain from changing climate conditions. Rising temperatures, shifting precipitation patterns, and extreme weather events are disrupting crop yields and threatening food production in every major agricultural region of the world. Heat stress is already reducing yields of major crops like wheat, rice, and maize in key production areas. For every degree Celsius of warming, wheat yields decline by 6%, rice yields by 3.2%, and maize yields by 7.4%. As temperatures continue to rise, these yield losses will accelerate, threatening food security for billions of people. Extreme weather events are causing massive crop failures and livestock losses. The 2012 drought in the United States, the worst in 50 years, caused $30 billion in agricultural losses and contributed to a spike in global food prices. Similar droughts in Australia, Argentina, and other major food-producing regions have disrupted global food supplies and increased food insecurity. At the same time, changing precipitation patterns are making farming more difficult and unpredictable. Some regions are experiencing more intense rainfall that causes flooding and soil erosion, while others face prolonged droughts that make crop production impossible without irrigation. The timing of rains is also shifting, disrupting planting and harvesting schedules that farmers have relied on for generations. Sea level rise is already forcing human communities to abandon their homes and seek new places to live. Small island nations like Tuvalu, Kiribati, and the Marshall Islands face complete submersion within decades, forcing entire populations to relocate. In Bangladesh, rising seas and more intense storms regularly flood coastal areas, displacing millions of people and contaminating freshwater supplies with salt water. Coastal cities around the world are experiencing more frequent flooding during high tides and storms. Miami, Venice, Bangkok, and Jakarta regularly experience flooding that disrupts daily life and damages infrastructure. The cost of protecting these cities from rising seas runs into hundreds of billions of dollars, and many may ultimately prove impossible to defend. Extreme heat is making parts of the world increasingly uninhabitable for human beings. Heat waves that would have been rare or impossible in the past are now becoming regular occurrences, with temperatures that can be deadly for anyone without access to air conditioning. The wet bulb temperature, a measure that combines heat and humidity, is approaching levels that make survival impossible even for healthy adults resting in the shade. In 2021, a heat dome over the Pacific Northwest caused temperatures to exceed 115 degrees F, 46 degrees C in cities like Portland and Seattle, killing more than 600 people. Similar extreme heat events have killed thousands in Europe, India, and other regions. As temperatures continue to rise, heat waves will become more frequent, longer-lasting, and more deadly. The health impacts of climate change extend far beyond heat-related deaths. Changing temperature and precipitation patterns are expanding the range of vector-borne diseases like malaria, dengue fever, and Zika virus. Warmer temperatures allow disease-carrying mosquitoes to survive in regions where they previously could not, exposing new populations to these diseases. Air pollution, worsened by rising temperatures and more frequent wildfires, is contributing to respiratory diseases and premature death. The World Health Organization estimates that climate change is already causing approximately 250,000 additional deaths annually from malnutrition, malaria, diarrhea, and heat stress. Mental health impacts are increasingly recognized as a major consequence of climate change. Extreme weather events cause trauma, anxiety, and depression that can persist long after the immediate danger has passed. The loss of homes, livelihoods, and familiar landscapes creates what psychologists call solastalgia, a form of distress caused by environmental change in one's home environment. Economic systems are struggling to cope with the mounting costs of climate impacts. Insurance companies are withdrawing coverage from high-risk areas or raising premiums to levels that many people cannot afford. The 2017 Atlantic hurricane season caused more than $200 billion in damages, while the 2019-2020 Australian bushfires caused economic losses exceeding $100 billion. Infrastructure systems designed for stable climate conditions are failing as extreme weather becomes more common. Roads buckle in extreme heat, railways warp, and airport runways become too hot for safe aircraft operations. Power grids fail during heat waves when air conditioning demand peaks, leaving millions without electricity when they need it most. The impacts of climate change are not distributed equally. The poorest and most vulnerable populations bear the greatest burden, despite contributing least to the problem. Developing countries, which have contributed only a small fraction of historical greenhouse gas emissions, are experiencing the most severe impacts from climate change. In sub-Saharan Africa, climate change is exacerbating existing challenges of poverty, conflict, and underdevelopment. Droughts in the Horn of Africa have displaced millions of people and contributed to famines that have killed hundreds of thousands. Lake Chad, once one of Africa's largest lakes, has shrunk by 90% since 1960, destroying the livelihoods of millions of people who depended on its waters for fishing and agriculture. Indigenous communities, who have lived sustainably on their traditional lands for thousands of years, are among the most severely affected by climate change. Arctic communities are seeing their traditional hunting and fishing grounds disappear as sea ice melts and permafrost thaws. Pacific Island communities are losing their ancestral lands to rising seas. Native American tribes in the southwestern United States are facing severe water shortages as rivers and lakes dry up. Climate migration is becoming one of the defining human challenges of the 21st century. The Internal Displacement Monitoring Center estimates that weather-related disasters displace an average of 24 million people annually, equivalent to displacing the entire population of Australia every year. By 2050, climate change could displace between 200 million and 1 billion people, creating the largest refugee crisis in human history. Most climate migrants move within their own countries, from rural areas affected by drought or sea level rise to urban areas that may offer more opportunities, but often lack the infrastructure to support large numbers of new residents. This internal migration is contributing to rapid urbanization and the growth of informal settlements, or slums where living conditions are often poor and vulnerable to extreme weather. International climate migration is more limited but growing. Small island nations are negotiating agreements to resettle their entire populations as their countries become uninhabitable. Drought and desertification in Central America are contributing to migration toward the United States. Climate impacts in the Middle East and North Africa are among the factors driving migration toward Europe. The security implications of climate change are becoming increasingly apparent. Competition for scarce water resources is contributing to conflicts in regions like the Middle East, the Sahel, and Central Asia. The Syrian civil war, which has displaced millions of people and destabilized an entire region, was partly triggered by a severe drought that destroyed rural livelihoods and drove people to cities. Military and security experts increasingly recognize climate change as a threat multiplier that exacerbates existing tensions and creates new sources of conflict. As climate impacts intensify, the risk of climate-related conflicts is likely to increase, particularly in regions that are already struggling with poverty, weak governance, and social tensions. Children and young people face particularly severe impacts from climate change, both because they are more vulnerable to heat, air pollution, and vector-borne diseases, and because they will live with the consequences of today's emissions for their entire lives. UNICEF estimates that 1 billion children, nearly half of all children worldwide, live in countries at extremely high risk from climate impacts. The psychological toll on young people is particularly severe, with many experiencing eco-anxiety and climate grief as they contemplate the world they are inheriting. Surveys show that a majority of young people are worried about climate change, and many are choosing not to have children because of concerns about the future. Women are disproportionately affected by climate change, particularly in developing countries, where they often have primary responsibility for water collection, food production, and caring for children and elderly family members. When droughts make water scarce, women and girls must walk longer distances to find water, often missing school or work. When extreme weather destroys crops, women are more likely to go hungry as they prioritize feeding other family members. Climate change is not just an environmental issue. It is a human rights issue, a development issue, a security issue, and a moral issue. The impacts we are already experiencing are just the beginning. Without dramatic action to reduce greenhouse gas emissions and help vulnerable communities adapt to climate change, the human toll will continue to mount. But even in the face of these overwhelming challenges, human ingenuity and resilience are finding ways to adapt and thrive. Communities are developing innovative solutions to manage water scarcity, protect coastlines, and maintain food security in a changing climate. Cities are implementing heat action plans to protect residents during extreme heat events. Farmers are developing climate-resilient crops and agricultural practices. The question is not whether we can adapt to some degree of climate change. We are already doing so. The question is whether we can limit climate change to levels that allow human civilization to continue flourishing, or whether we will face impacts so severe that they overwhelm our capacity to adapt. The human impact of climate change is not a future concern. It is a present reality affecting billions of people today. The choices we make in the next few years will determine whether we can minimize this suffering and build a more resilient world, or whether we will condemn future generations to even greater hardship. The time for action is now. Chapter 7. Catastrophic Scenario 2100. The year is 2100. The world has changed beyond recognition. As you step outside, the thermometer reads 52 degrees C in the shade, and it's only April. The sun beats down mercilessly through a hazy atmosphere thick with dust and smoke from perpetual wildfires. This is the new normal in what was once called the temperate zone. Humanity has pushed the planet beyond its breaking point, and we are now living with the consequences. Global average temperatures have risen by 5 degrees C above pre-industrial levels, a change that has fundamentally altered the habitability of large portions of the Earth. The Arctic, once a realm of ice and snow, is now an open ocean for most of the year. The last remnants of Arctic sea ice disappear each summer, eliminating a crucial component of the planet's climate system that had regulated global temperatures for millions of years. The great ice sheets of Greenland and West Antarctica have largely collapsed, raising sea levels by more than 8 meters. The world map has been redrawn by the relentless rise of the oceans. Miami, Venice, Bangkok, Mumbai, and countless other coastal cities now lie beneath the waves, their skyscrapers serving as artificial reefs for the few marine species that have managed to survive in the increasingly acidic and oxygen-poor oceans. The Netherlands, a nation that spent centuries fighting the sea, has finally lost the battle. The massive engineering projects that once held back the North Sea have been overwhelmed by storm surges and rising waters. Similar stories have played out around the world. Bangladesh is almost entirely submerged, forcing its 200 million inhabitants to flee to higher ground. The Maldives, Tuvalu, and other low-lying island nations exist now only in history books and the memories of climate refugees. New York City's famous subway system lies flooded and abandoned, its tunnels serving as underwater passages in a drowned metropolis. The city's remaining inhabitants live in the upper floors of the tallest buildings, connected by boat networks and elevated walkways. Wall Street's financial district is now literally underwater, though the global economy collapsed decades ago as climate impacts overwhelmed human institutions. London's Thames Barrier, once a symbol of human engineering prowess, was abandoned in 2087 after being breached for the 15th time in a single year. The ancient city now exists as an archipelago of islands connected by water taxis and elevated trains. The Houses of Parliament, where debates about climate action once took place, now hosts emergency refugee shelters on its upper floors. In this catastrophic world, the habitability of large regions has been destroyed by extreme heat. Vast areas of the Middle East, North Africa, South Asia, and the southwestern United States have become uninhabitable due to wet bulb temperatures that exceed the limits of human survival. Even with air conditioning, for those who can afford it and where electricity is available, prolonged exposure to these conditions is fatal. The great cities of the Persian Gulf, Dubai, Kuwait City, Riyadh, stand as monuments to failed adaptation, their gleaming skyscrapers rising from landscapes too hot for human habitation. The wealthy elite who once inhabited these air-conditioned towers have long since fled to climate havens in higher latitudes, leaving behind empty shells of concrete and glass slowly being reclaimed by sand dunes that advance unchecked. India, home to nearly 2 billion people at the start of the century, has been largely evacuated. The monsoons that once brought life-giving rains have become erratic and violent, alternating between devastating floods and multi-year droughts. When the rains do come, they arrive as atmospheric rivers that dump months of precipitation in days, causing floods that wash away entire cities. The Ganges, once considered holy and eternal, now runs dry for months at a time, its waters diverted for desperate irrigation attempts or lost to evaporation in the brutal heat. The mass migration that began in the 2040 has reshaped human geography. Climate refugees number in the billions, creating the largest movement of people in human history. The fortunate have found shelter in the remaining habitable zones, parts of Canada, Scandinavia, Siberia, Patagonia, and Tasmania. But even these climate havens are struggling to accommodate the endless streams of displaced humanity. Fortress-like walls and militarized borders now surround the world's remaining habitable regions. Canada, once known for its welcoming immigration policies, has built a series of barriers along its southern border to control the flow of climate migrants from the uninhabitable regions of the United States. Similar barriers exist along the borders of Scandinavia, Russia, and other high-latitude nations that have become refuges for climate survivors. The social fabric of human civilization has been torn apart by the scale of displacement and resource competition. Wars rage constantly along the borders of habitable and uninhabitable zones. The lucky residents of climate havens live in air-conditioned enclaves, dependent on desalination plants for water and vertical farms for food. The less fortunate exist in sprawling refugee camps that stretch to the horizon, living in conditions of desperate poverty while dreaming of a cooler past that their children will never know. Agriculture, as we once knew, it has ceased to exist in most of the world. The great grain belts that once fed humanity, the American Midwest, the Ukrainian steppes, the Australian wheat belt, have become dust bowls where nothing grows except in carefully controlled indoor facilities. The soil, baked by relentless heat and stripped of nutrients by desperate overuse, blows away in dust storms that can be seen from space. Food production has retreated to the polar regions, where the ground remains soft enough to cultivate. Enormous greenhouse complexes stretch across Siberia and northern Canada, producing genetically modified crops designed to survive in the harsh conditions of this new world. But even these technological marvels cannot produce enough food for the billions of climate refugees, leading to chronic malnutrition and famine on a scale never before witnessed. The world's forests have largely vanished, consumed by wildfires that burn perpetually across entire continents. The Amazon rainforest, once the lungs of the earth, burned completely in a series of megafires during the 2070, releasing billions of tons of stored carbon and accelerating climate change even further. The great boreal forests of Canada and Russia met similar fates, leaving behind charred stumps and ash-covered wastelands that serve as monuments to humanity's failure to protect the natural world. What remains of wildlife exists only in carefully controlled reserves and zoos. The polar bear, symbol of climate change, went extinct in 2089 when the last female died in captivity. The great coral reefs, once teeming with life, have been replaced by underwater graveyards of bleached calcium carbonate skeletons. The ocean food web has largely collapsed, with only jellyfish and bacteria thriving in the acidic, oxygen-depleted seas. Fresh water has become more precious than gold. The great rivers, the Colorado, the Murray, the Yellow River, have been dry for decades, their riverbeds serving as highways through landscapes too dry to support vegetation. The remaining freshwater exists in underground aquifers that are carefully guarded by military forces and rationed to the highest bidders. Desperate geoengineering projects have scarred the landscape and atmosphere. Massive solar radiation management systems spray reflective particles into the stratosphere, creating artificial sunsets of unnatural colors. Enormous machines attempt to suck carbon dioxide from the atmosphere, but they are too late to reverse the changes already set in motion. The sky itself has become artificial, engineered by humans in a desperate attempt to make their planet habitable again. Disease runs rampant in this overheated world. Tropical diseases have spread to every continent as mosquitoes and other vectors find suitable habitat in regions that were once too cold for them. New pathogens emerge from thawing permafrost and stressed ecosystems, finding easy targets in malnourished and immunocompromised populations. The medical infrastructure that once controlled these diseases has collapsed under the strain of caring for billions of climate refugees. Energy systems have fundamentally changed in this world of extremes. Solar panels, ironically, have become less effective in many regions due to extreme heat and dust storms. Wind patterns have shifted so dramatically that existing wind farms stand useless, their turbines stilled by the disrupted atmospheric circulation. Most energy now comes from nuclear fusion plants that power the air conditioning systems and vertical farms that keep humanity alive in its remaining habitable enclaves. The Internet, once a global network connecting all of humanity, has fragmented into isolated regional networks as submarine cables are severed by sea level rise and infrastructure collapses under extreme weather. Much of humanity's digital heritage has been lost as data centers are abandoned or destroyed by climate impacts. Children born in this world know only struggle and scarcity. They have never seen a stable climate, abundant nature, or the prosperity that previous generations took for granted. Their education consists primarily of survival skills and technical knowledge needed to maintain the life support systems that keep their communities habitable. They learn about forests, coral reefs, and polar ice from archived videos and virtual reality simulations, never experiencing these wonders in person. Mental health has become the silent epidemic of this climate-changed world. Rates of depression, anxiety, and suicide have soared as people struggle to cope with the loss of everything familiar and hopeful. Solastalgia, the distress caused by environmental change in one's home environment, affects billions of people who have watched their homelands become uninhabitable. Art and culture in this world reflect the trauma of planetary collapse. Music is melancholy and nostalgic, filled with longing for a cooler, more stable past. Literature focuses on themes of loss, adaptation, and the search for hope in a seemingly hopeless world. Museums preserve artifacts from the before times, photographs of glaciers, recordings of extinct birds, samples of clear mountain air sealed in glass containers. Religion and spirituality have evolved to address the reality of living on a damaged planet. New forms of worship emerge that focus on repentance for humanity's destruction of creation and prayers for the dead worlds that once existed. Some find comfort in apocalyptic beliefs that see current suffering as a prelude to redemption. Others embrace a grim materialism that focuses solely on survival in a world without transcendent meaning. The global economy exists only in the most rudimentary form. Traditional concepts of growth and development are meaningless in a world focused solely on survival. Currency has been replaced by systems of resource allocation and refugee quotas. The stock markets that once drove global capitalism are extinct, their buildings flooded or abandoned. Technology has advanced in narrow, specialized areas focused on survival and adaptation. Artificial intelligence manages complex resource allocation systems and operates automated life support systems. Biotechnology creates new crops and medicines for a world of extremes. But innovation has slowed dramatically as human society focuses all its energy on meeting basic needs rather than exploring new frontiers. This is a world where humanity survives, but barely, where the remnants of our species cling to existence in a few remaining habitable zones, while most of the planet has become a hellscape of heat, drought, and storms, where the rich nations that could once have led a transition to sustainability have become fortress states protecting their remaining resources from billions of desperate climate refugees. It is a world where the cost of inaction on climate change has been paid in full, in the form of civilizational collapse, mass extinction, and human suffering on a scale that defies comprehension, where the warnings of scientists in the early 21st century have come to pass in the most devastating way imaginable. This catastrophic future is not inevitable, but it becomes more likely with every day of delay in taking serious action to reduce greenhouse gas emissions and prepare for climate impacts. The choices made today will determine whether this nightmare scenario becomes reality or remains a cautionary tale that motivated humanity to choose a different path. In this world of 2100, the survivors look back on the early 21st century as the time when everything could have been different, when humanity still had the power to choose its future. They wonder why their ancestors, with all their knowledge and technology, chose to continue down a path that led to such devastation. They wonder why the warnings were ignored, why the science was denied, why short-term profits were prioritized over long-term survival. The catastrophic scenario of 2100 represents the ultimate failure of human civilization, not just our failure to solve the climate crisis, but our failure to learn, adapt, and cooperate in the face of an existential threat. It is a future that must never be allowed to come to pass. Chapter 8. Moderate Scenario 2100. The year is 2100. And the world bears the scars of humanity's struggle with climate change. This is not the worst-case scenario that climate scientists once warned about, but neither is it the future that activists and innovators dreamed of creating. It is a world of adaptation and resilience, but also of profound inequality and irreversible loss. It is a world where humanity has learned to survive climate change, but has not yet learned to thrive despite it. Global temperatures have risen by 3 degrees C above pre-industrial levels, enough to fundamentally alter the planet's climate system, but not enough to trigger the most catastrophic tipping points that scientists feared. This warming has been achieved through a combination of gradual emissions reductions, starting in the 2020, and massive geoengineering projects that began in earnest during the 2040. The result is a planet that is dramatically different from the one our grandparents knew, but one where human civilization has found a way to continue. The world map of 2100 tells a story of managed retreat and strategic adaptation. Sea levels have risen by 3 meters, enough to redraw coastlines around the world but not enough to completely submerge major cities. Miami exists now as the Venice of the Americas, its downtown core permanently flooded but connected by an intricate network of canals, water taxis, and elevated walkways. The city's remaining residents have embraced their aquatic lifestyle, with floating neighborhoods and underwater shopping centers becoming tourist attractions. New York City has survived through one of the greatest engineering projects in human history. The entire city is now protected by a massive sea wall that stretches from Staten Island to the Bronx, with enormous gates that can close to protect the harbor during storm surges. The subway system has been completely rebuilt and waterproofed, while new developments are built on stilts or floating platforms. Manhattan's skyline now includes wind turbines and solar panels on every building, making the city carbon negative despite its dense population. London has implemented its Thames Estuary 2100+ project, a series of movable barriers and elevated neighborhoods that protect the city from rising seas and increased flooding. The Thames now regularly flows through the heart of the city at levels that would have been considered catastrophic flooding in the early 21st century. But Londoners have adapted with floating markets, amphibious buses, and buildings designed to rise and fall with the tides. In the developing world, adaptation has followed a different path. Bangladesh, rather than fighting the rising seas, has embraced its transformation into an aquatic nation. The country has become a leader in floating agriculture, with vast fields of rice and vegetables growing on the surface of shallow seas. Floating cities house millions of people in structures that rise and fall with the tides, powered by ocean thermal energy conversion and sustained by aquaculture and desalination. The Netherlands has extended its legendary flood management expertise to become the world's leading exporter of climate adaptation technology. Dutch companies design and build sea walls, floating neighborhoods, and water management systems for coastal cities around the world. The country itself has survived behind a network of barriers that would have been unimaginable to previous generations, while much of its territory has been converted to floating agricultural systems. Climate migration has reshaped human geography, but not in the chaotic, violent way that many feared. The Great Climate Migration of the mid-21st century saw approximately 1.5 billion people relocate from the most affected regions to climate havens in higher latitudes. While this movement created enormous challenges, international cooperation and early warning systems prevented the worst humanitarian disasters. Canada has become home to 200 million climate migrants, transforming the country from a sparsely populated northern nation to one of the world's demographic powerhouses. New cities have sprouted across the Canadian prairies and boreal regions, designed from the ground up to be carbon neutral and climate resilient. Toronto and Vancouver have grown into megacities of 20 million people each, while entirely new urban centers like New Calgary and Arctic City house millions of newcomers. Siberia has undergone a similar transformation, becoming Russia's new agricultural heartland as the permafrost thaws and temperatures warm enough to support large-scale farming. The Trans-Siberian Railway has been expanded into a vast transportation network, connecting dozens of new cities built to house climate migrants from Central Asia and the Middle East. Despite initial tensions, Russia has embraced its role as a climate haven, recognizing the economic benefits of its expanded population and workforce. Scandinavia has become the Switzerland of the North, a region of prosperity and stability that attracts climate migrants, international corporations, and refugees from less stable regions. Oslo and Stockholm have grown into major global financial centers, while new cities in northern Sweden and Finland house millions of people who have fled rising seas and extreme heat in southern Europe and Africa. The global economy has been fundamentally restructured around climate adaptation and mitigation technologies. The Green New Deal initiatives of the 2020s and 2030 created entirely new industries focused on renewable energy, climate adaptation, and ecosystem restoration. By 2100, these green industries represent the largest sector of the global economy, employing hundreds of millions of people in jobs that did not exist a century earlier. Solar energy dominates global electricity production, with massive solar installations covering areas of desert that were once considered worthless. The Sahara Solar Project, a joint venture between African nations and European companies, produces enough electricity to power most of Africa and exports surplus energy to Europe via undersea cables. Similar projects in the Gobi Desert, the Australian outback, and the American Southwest have transformed these regions into energy powerhouses. Wind power has evolved far beyond the turbines of the early 21st century. Massive offshore wind farms in the North Sea, the Atlantic, and the Pacific generate enormous amounts of electricity, while high-altitude wind systems capture the powerful jet stream winds to produce energy around the clock. Floating wind platforms follow the strongest winds across the oceans, beaming power to coastal receivers via microwave transmission. Nuclear fusion, after decades of promise and delay, finally became commercially viable in the 2060s. By 2100, fusion plants provide baseload power for most developed nations, offering clean, abundant energy without the risks of fission or the intermittency of renewables. These plants have enabled the massive desalination and carbon capture projects that help sustain human civilization in a climate-changed world. Agriculture has been revolutionized by the need to feed 11 billion people on a planet with less arable land and more extreme weather. Vertical farms now produce most of the world's fruits and vegetables, using 90% less water and land than traditional farming while completely eliminating pesticide use. These climate-controlled growing facilities can be found in every major city, reducing food transport emissions and providing fresh produce year-round regardless of external weather conditions. Cellular agriculture has transformed protein production, with lab-grown meat, fish, and dairy products comprising 80% of global protein consumption. This transition has eliminated the need for livestock farming in many regions, freeing up vast areas of land for reforestation and ecosystem restoration. The remaining traditional farms focus on high-quality, artisanal products for consumers who prefer conventional agriculture. Ocean farming has become a major source of food, with vast kelp forests and shellfish farms covering millions of square kilometers of ocean surface. These marine farms not only produce food, but also sequester carbon and help restore ocean ecosystems damaged by acidification and warming. Floating cities often integrate these marine farms into their design, creating self-sustaining communities that produce their own food and energy. Water management has become one of the most critical technologies of the 21st century. Massive desalination plants powered by renewable energy provide fresh water for coastal cities and agricultural regions. Atmospheric water generators extract moisture from the air, even in desert regions, while advanced recycling systems turn wastewater into drinking water with higher purity than most natural sources. The Middle East, once dependent on fossil fuel exports, has become a leader in water and solar technology. Countries like Saudi Arabia and the UAE have built their new economies around solar energy production and advanced desalination, exporting both electricity and fresh water to neighboring regions. The ancient dream of making the desert bloom has been realized through technology rather than conquering nature. Transportation has been completely electrified and largely automated. Personal vehicles are predominantly electric and shared, with most cities implementing comprehensive public transit systems powered by renewable energy. High-speed rail networks connect major population centers across continents, while electric aircraft handle shorter routes and cargo transport. The shipping industry has been transformed by wind-assisted electric cargo ships, which use a combination of modern sail technology and electric propulsion to move goods with minimal emissions. Some shipping routes are served by automated cargo submarines that travel beneath the often stormy surface waters of the climate-changed oceans. Geoengineering projects, once considered too risky to attempt, have become routine parts of climate management. Solar radiation management systems spray reflective particles into the stratosphere to reduce incoming solar radiation, helping to keep global temperatures from rising even higher. These systems require careful international coordination and constant monitoring, but have proven effective at buying time for emissions reductions to take effect. Massive direct air capture facilities remove billions of tons of CO2 from the atmosphere each year, powered by the abundant renewable energy that has become cheaper than fossil fuels ever were. The captured carbon is either stored underground or used to produce synthetic fuels, plastics, and building materials. While these facilities cannot reverse all the damage that has been done, they are slowly beginning to reduce atmospheric CO2 concentrations. Ecosystem restoration has become a major global industry, employing millions of people in projects to restore forests, wetlands, coral reefs, and other damaged ecosystems. The Great Green Wall of Africa has been completed, creating a belt of restored forest and grassland across the continent that provides habitat for wildlife, sequesters carbon, and supports local communities. Coral reef restoration projects using heat-resistant coral species and artificial reef structures have managed to save about 30% of the world's reefs. While this represents a massive loss compared to the early 21st century, it is far better than the complete collapse that once seemed inevitable. These restored reefs support both marine ecosystems and coastal tourism industries. Urban forests and green infrastructure have transformed cities around the world. Singapore's model of a city in a garden has been replicated globally, with every major city incorporating extensive green spaces, vertical gardens, and urban forests. These green infrastructure systems help manage stormwater, reduce urban heat islands, and provide habitat for wildlife even in dense urban environments. However, this moderate future is far from utopian. The benefits of climate adaptation and green technology are not equally distributed. Wealthy nations and communities have successfully adapted to climate change through technology and infrastructure, while poorer regions continue to struggle with the impacts of a changed climate. Africa, despite massive international assistance and investment in climate adaptation, still faces significant challenges. The Sahel region has been largely abandoned as desertification made farming impossible, forcing hundreds of millions of people to migrate to coastal cities or other continents. While new cities in East Africa have become models of sustainable development, much of the continent still struggles with water scarcity, extreme heat, and ecosystem collapse. Small island nations have faced varying fates in this moderate scenario. Some, like the Maldives and Tuvalu, have been completely abandoned as sea level rise made them uninhabitable. But others, like Barbados and Fiji, have successfully adapted through floating platforms, sea walls, and elevated development. These surviving island nations have become symbols of successful climate adaptation, but their survival has come at enormous cost. India has managed to avoid complete collapse through massive infrastructure investments and international assistance, but the country has been fundamentally transformed. The Ganges and other major rivers flow only seasonally, requiring enormous water storage and management systems to sustain urban populations. Much of the population has migrated to the cooler highland regions or emigrated to other countries, leaving vast areas of the Indo-Gangetic Plain sparsely populated. Social inequality has been exacerbated by climate change and the costs of adaptation. The wealthy live in climate-controlled cities with reliable water supplies, abundant food, and protection from extreme weather. But hundreds of millions of people still live in vulnerable conditions, working in outdoor jobs that expose them to dangerous heat, living in flood-prone areas that cannot afford adequate protection, or struggling with water and food insecurity. Mental health has become a major global challenge, with billions of people suffering from climate anxiety, grief for lost environments, and trauma from extreme weather events. New forms of therapy and community support have emerged to help people cope with living in a fundamentally changed world. But the psychological toll of climate change affects everyone. Education systems have been completely restructured around climate literacy and adaptation skills. Children learn about ecosystem restoration, renewable energy systems, and climate science as core subjects. Universities focus on training the workforce needed for the green economy, with degrees in fields like climate adaptation engineering, ecosystem restoration, and fusion energy management becoming some of the most sought-after credentials. Art and culture reflect both the losses and adaptations of this climate-changed world. Museums preserve examples of extinct ecosystems and species for future generations, who will never see them in the wild. Music and literature often focus on themes of resilience, adaptation, and the complex relationship between humans and their transformed environment. Religion and spirituality have evolved to address the realities of living on a damaged planet. Many faiths have embraced environmental stewardship as a central tenet, while new spiritual movements focus on humanity's responsibility to heal the earth. Climate adaptation is often framed in religious terms as a moral imperative and an expression of hope for future generations. Technology continues to advance, but within the constraints of a climate-changed world. Artificial intelligence manages complex climate systems and adaptation infrastructure. Biotechnology develops new species able to survive in changed environments. Space technology is used primarily for Earth observation and climate monitoring, with colonization efforts limited by the enormous resources required for terrestrial climate adaptation. International cooperation has been strengthened by the shared challenge of climate change, but tensions remain high. Climate debt, the concept that wealthy nations owe compensation to poorer countries for historical emissions, has become a major source of international conflict. Migration and resource allocation continue to strain diplomatic relations, even as nations work together on geoengineering and adaptation projects. The moderate scenario of 2100 represents a world where humanity has learned to survive climate change, but at enormous cost. It is a world of technological marvels and successful adaptation, but also of profound inequality and irreversible loss. Billions of people live comfortable, secure lives, while billions more struggle with the ongoing impacts of a damaged climate system. This is a world where the warnings of early 21st century scientists were heeded just enough to avoid complete catastrophe, but not enough to prevent massive suffering and ecosystem collapse. It is a world where human ingenuity and cooperation have proven capable of remarkable achievements, but where the price of delay and inadequate action continues to be paid by the most vulnerable populations. The moderate scenario represents both a failure and a success. A failure to prevent dangerous climate change, but a success in adapting to its consequences. It is a world that future generations might look upon with a mixture of admiration for human resilience and regret for the opportunities that were missed in the early 21st century. This future is neither the best nor the worst that we can imagine, but it may be the most realistic given current trends and policies. It represents what might happen if we continue on our current trajectory of gradual progress on climate action, technological innovation, and international cooperation, but without the transformative changes needed to prevent dangerous climate change. Whether this moderate future comes to pass, or whether we can still achieve something better, depends on the choices we make today. The next decade will be crucial in determining which version of 2100 becomes reality. Chapter 9. Positive Scenario 2100. The year is 2100, and Earth is healing. As morning breaks over a world transformed by 8 decades of unprecedented human cooperation and innovation, the first rays of sunlight illuminate a planet that has been pulled back from the brink of climate catastrophe. This is not the same Earth that existed in 2020. Too much damage was done, too many species were lost, too many systems were disrupted for that. But it is a world that has found a new balance, a different kind of beauty, and most importantly, hope for the future. Global temperatures peaked at 1.8 degrees C above pre-industrial levels in the 2040, and have since stabilized at 1.5 degrees C as massive carbon removal systems, combined with decades of net negative emissions, began to draw down atmospheric CO2 concentrations. The Paris Agreement target, once thought impossible to achieve, was not only met but exceeded through an unprecedented mobilization of human ingenuity, resources, and political will. The transformation began in the 2020 with what historians now call the Great Transition, a decade of revolutionary changes in energy, transportation, industry, and agriculture that laid the foundation for the restoration of planetary systems. By 2030, renewable energy provided 80% of global electricity. By 2040, fossil fuels had been almost entirely phased out except for a few specialized applications. By 2050, human civilization had achieved net negative emissions, removing more CO2 from the atmosphere than it produced. The world map of 2100 tells a story of restoration and regeneration. Where deserts once advanced, green belts of restored forests and grasslands now stretch across continents. The Great Green Wall of Africa, completed in 2055, extends from Senegal to Somalia, providing a barrier against desertification while supporting millions of livelihoods and sequestering billions of tons of carbon. Forests cover more of the planet than they did in 2020, despite supporting a population of 10.5 billion people. This has been achieved through a combination of reforestation, afforestation, and the development of incredibly efficient urban agriculture systems that require only a fraction of the land that traditional farming once needed. The Amazon rainforest, saved from the brink of collapse by international intervention in the 2020, now covers an even larger area than it did before European colonization, serving as both a massive carbon sink and a repository of biodiversity. The oceans, once acidifying and depleted, are showing remarkable signs of recovery. A combination of reduced CO2 emissions, massive alkalinization projects, and careful ecosystem management has begun to restore ocean pH levels and marine ecosystems. Coral reefs, supported by heat-resistant species developed through careful genetic selection and advanced coral gardening techniques, are growing again in tropical waters around the world. Whale populations have recovered to pre-whaling levels, with the oceans once again filled with the songs of these magnificent creatures. Fish populations have rebounded as marine protected areas now cover 50% of the ocean surface, allowing ecosystems to restore themselves while still providing sustainable yields for human consumption. The cities of 2100 are marvels of integration between human technology and natural systems. Singapore's vision of a city in a garden has become the global standard, with every major urban area incorporating extensive green infrastructure, urban forests, and integrated natural systems. Buildings are living structures that purify air, manage water, and provide habitat for wildlife while housing and serving human communities. New York City exemplifies this transformation. Central Park has been expanded to connect with green corridors that run through every borough, creating a continuous network of urban wilderness. The Hudson River runs cleaner than it has in centuries, supporting populations of fish and wildlife that had disappeared decades ago. Manhattan's skyline is green, with vertical forests growing up the sides of carbon-negative skyscrapers, powered entirely by renewable energy. The High Line, once a symbol of urban renewal, has been replicated and expanded throughout the city, creating elevated gardens and wildlife corridors that connect neighborhoods and provide habitat for migrating birds. Every neighborhood has abundant green space, urban farms and community gardens that provide fresh food while storing carbon and managing stormwater. Paris has achieved its goal of becoming carbon negative, with the Seine flowing clear through a city where every building is a net producer of renewable energy. The Champs-Élysées has been converted to an urban forest, while high-speed electric trains connect the city to every corner of Europe without a single emission. The Eiffel Tower, retrofitted with advanced wind and solar systems, generates more energy than the entire 7th arrondissement consumes. London has embraced rewilding on an unprecedented scale, with extensive urban forests and restored wetlands throughout the metropolitan area. The Thames estuary has been transformed into a massive tidal wetland that provides habitat for millions of migratory birds while protecting the city from storm surges. Wolves have been reintroduced to the Scottish Highlands, and their presence has restored natural balance to ecosystems that had been degraded for centuries. Energy systems in 2100 are clean, abundant, and nearly free. Solar panels with 60% efficiency cover vast areas of desert, generating more electricity than human civilization can use. Advanced battery systems and hydrogen storage provide reliable power, even when the sun isn't shining and the wind isn't blowing. Ocean thermal energy conversion systems tap the temperature differences in tropical seas to provide continuous baseload power. Nuclear fusion, finally mastered in the 2050, provides clean energy for the most demanding applications, while thorium reactors recycle nuclear waste from the fossil fuel era. Space-based solar power stations beam energy to Earth via microwave transmission, providing clean electricity even to the most remote locations. The breakthrough came not from a single technology, but from the integration of dozens of innovations, Perovskite solar cells that can be painted onto any surface, wind turbines that operate silently and safely in urban environments, geothermal systems that can tap Earth's heat anywhere on the planet, and tidal generators that harness the power of the oceans without disrupting marine life. Transportation in 2100 is electric, efficient, and integrated with natural systems. Personal vehicles are shared autonomous electric pods that operate as part of an integrated transportation network. High-speed rail connects every major population center, powered entirely by renewable energy, and designed to cause minimal disruption to wildlife migration patterns. Aviation has been revolutionized by hydrogen fuel cells and advanced battery technologies, allowing for zero-emission flights across any distance. Electric aircraft powered by advanced batteries handle short-haul routes, while hydrogen planes serve long-haul routes. The few remaining fossil fuel aircraft are used only for cargo transport to the most remote locations, and these are being rapidly phased out. Shipping has been completely transformed by wind-assisted electric vessels that use a combination of modern sail technology, hydrogen fuel cells, and advanced batteries to move cargo with zero emissions. Some routes are served by automated cargo submarines that travel beneath the surface, avoiding storms while causing minimal disruption to marine life. Agriculture in 2100 represents a complete revolution in how humans produce food. Vertical farms in urban areas produce most fruits and vegetables, using 95% less water and 90% less land than traditional farming, while completely eliminating pesticides and fertilizers. These climate-controlled growing facilities can produce multiple harvests per year and operate regardless of external weather conditions. Cellular agriculture has matured to the point where lab-grown meat, fish, and dairy products are cheaper and more nutritious than their traditional counterparts. This transition has eliminated the need for industrial livestock farming, freeing up billions of acres of land for ecosystem restoration, while dramatically reducing greenhouse gas emissions and water consumption. Ocean farming has become a major source of food, with vast kelp forests and shellfish farms covering millions of square kilometers of ocean surface. These marine farms not only produce protein but also sequester carbon, restore ocean ecosystems, and provide habitat for marine life. Traditional farming continues in areas where it provides ecological benefits, but it looks very different from the agriculture of the early 21st century. Regenerative farming practices have restored soil health and turned farmland into carbon sinks. Integrated pest management and companion planting have eliminated the need for synthetic pesticides, while composting and advanced biochar production have replaced synthetic fertilizers. The genetic diversity of crops has been dramatically expanded through careful preservation and breeding programs, making food systems more resilient to changing conditions. Indigenous varieties of rice, wheat, corn, and other staples have been restored and improved, providing better nutrition while requiring fewer inputs. Water systems in 2100 are circular and regenerative. Advanced desalination powered by renewable energy provides fresh water for coastal cities, while atmospheric water generators can extract moisture from the air, even in desert regions. Wastewater is completely recycled, with advanced treatment systems producing water that is purer than most natural sources. Wetlands have been restored on a massive scale, serving as natural water treatment systems while providing habitat for wildlife and protection from floods. Urban watersheds are managed as integrated systems, with green roofs, permeable surfaces, and constructed wetlands managing stormwater while providing ecosystem services. The atmospheric rivers that once caused devastating floods are now captured and stored in massive underground aquifers and surface reservoirs, providing water security for urban and agricultural areas during dry periods. Weather modification systems can seed clouds to increase precipitation where needed, while advanced forecasting allows for precise water management. The natural world has experienced a remarkable recovery in this positive future. The global rewilding movement has restored ecosystems across every continent, with large predators reintroduced to landscapes where they had been absent for centuries. Wolves, bears, and big cats once again roam forests and grasslands, maintaining natural balance and supporting ecosystem health. Biodiversity has stabilized and begun to recover, as habitat destruction has been reversed and climate change has been limited. While many species were lost during the crisis decades of the early 21st century, conservation efforts have prevented further extinctions and supported the recovery of endangered species. De-extinction technologies have been used selectively to restore keystone species that played crucial roles in ecosystem function. Woolly mammoths once again graze the Arctic tundra, helping to preserve permafrost through their grazing and trampling behaviors. Passenger pigeons have been restored to North American forests, while Tasmanian tigers hunt again in Australian wilderness areas. Coral reefs have not only survived, but are more diverse and resilient than they were in the early 21st century. Careful genetic management has created coral communities that can withstand higher temperatures and acidity levels, while innovative restoration techniques have expanded reef coverage in many tropical regions. Human society, in 2100, has been transformed by the need to live sustainably within planetary boundaries. The circular economy is complete, with nothing wasted and everything recycled or reused. Advanced materials science has created substances that are stronger and more versatile than traditional materials, while being completely biodegradable or recyclable. Nanotechnology and biotechnology work together to create materials that are grown rather than manufactured, using biological processes to produce everything from construction materials to electronics. Buildings are constructed from engineered wood and bioconcrete that actually sequester carbon as they age. Education systems have been revolutionized around ecological literacy and systems thinking. Children learn about natural systems, renewable energy, and sustainable design as core subjects. Universities focus on interdisciplinary programs that integrate technology, ecology, and social systems. The global economy has been restructured around sustainability and well-being rather than pure growth. The green industries that emerged during the Great Transition now represent the dominant sectors of the global economy, providing meaningful employment for billions of people in jobs that actively improve environmental and social conditions. Universal basic income, funded by carbon taxes and resource rents, provides economic security for all people while supporting the transition to more sustainable lifestyles. Work weeks are shorter, allowing more time for family, community, and personal development, while automation handles most routine and dangerous tasks. Healthcare has been revolutionized by personalized medicine, advanced biotechnology, and a focus on prevention rather than treatment. Life expectancy has increased while healthcare costs have decreased, as cleaner environments and better nutrition have reduced the incidence of many diseases. Mental health has improved dramatically as people live in cleaner, greener environments with stronger community connections and greater economic security. The anxiety and despair that characterized the early 21st century have been replaced by hope and engagement as people see tangible progress in healing the planet. International cooperation has reached unprecedented levels, with global governance systems that can effectively manage planetary resources and respond to emerging challenges. The climate crisis forced humanity to develop new forms of cooperation and decision-making that transcend national boundaries and short-term interests. Climate engineering technologies are used carefully and sparingly to maintain planetary systems within safe operating boundaries. Advanced weather modification can prevent extreme events, while large-scale carbon removal systems fine-tune atmospheric composition. These technologies are governed by international agreements that ensure they are used for the benefit of all humanity. Space technology has advanced dramatically, but remains focused primarily on Earth observation and planetary management. Satellites monitor ecosystem health, track carbon flows, and provide early warning for natural disasters. Space-based solar power provides clean energy to remote locations, while asteroid mining provides materials for terrestrial use without environmental destruction. Art and culture in this positive future celebrate both human achievement and natural beauty. Cities are filled with public art that integrates natural elements, while music and literature explore themes of restoration, cooperation, and hope. Museums showcase the recovery of ecosystems and species, documenting humanity's journey from the brink of ecological collapse to planetary restoration. Religion and spirituality have evolved to embrace humanity's role as stewards of creation, with environmental protection seen as a sacred duty across all faiths. New spiritual movements celebrate the interconnectedness of all life and humanity's responsibility to future generations. This positive future is not utopian. Challenges remain, and the scars of the early 21st century are still visible. Some species were lost forever, some landscapes permanently changed, and some communities displaced by rising seas. But it is a future where humanity has learned to live in harmony with natural systems, where technology serves both human needs and ecological restoration, and where hope has replaced despair. The transformation was not easy. It required unprecedented cooperation, massive investments in new technologies, and fundamental changes in how human societies organize themselves. It required overcoming powerful vested interests, deeply ingrained habits, and the natural human tendency towards short-term thinking. But it was achieved because enough people recognized that the alternative, ecological collapse and civilizational failure, was unacceptable. It was achieved because young people refused to accept a degraded future and demanded action from their leaders. It was achieved because scientists, engineers, entrepreneurs, and activists worked together to create the technologies and policies needed for planetary restoration. The positive scenario of 2100 represents what is possible when human ingenuity is directed toward healing rather than exploitation, when technology is used to restore rather than degrade natural systems, and when cooperation replaces competition as the dominant mode of human interaction. This future is not guaranteed, but it is achievable. The technologies needed already exist or are rapidly being developed. The policies required are well understood. The economic benefits far outweigh the costs. What is needed now is the political will and social mobilization to make it happen. The choice between this positive future and the alternatives described earlier is the defining challenge of our time. The next decade will determine which path humanity takes, and whether our species will be remembered as the one that nearly destroyed the planet or the one that learned to heal it. The future is still being written, and we all have a role to play in determining how the story ends. Chapter 10. The Human Legacy. As we stand at the threshold of 2025, looking toward an uncertain future, we find ourselves at the most consequential crossroads in human history. The story of the next 75 years is not yet written, but the opening chapters are being drafted now, with every policy decision, every technological innovation, every individual choice adding lines to the narrative that will define human civilization for centuries to come. The three scenarios we have explored, catastrophic, moderate, and positive, are not merely abstract possibilities but potential realities whose probability depends entirely on the actions we take in the next few years. We possess something that no generation in human history has ever had: the scientific knowledge to understand precisely how our actions affect the planetary systems that sustain us, and the technological capability to reshape those systems for better or worse. This knowledge brings with it an unprecedented responsibility. We cannot claim ignorance about the consequences of our choices. We cannot say we didn't understand the risks or didn't see the warning signs. The science is clear, the impacts are visible, and the pathways forward are well defined. What remains to be determined is whether we will choose to act on what we know. The decisions being made in boardrooms and government buildings around the world today will reverberate through the centuries. The coal plants built today will emit carbon dioxide for decades. The forests cut down today will take centuries to regrow. The species driven to extinction today can never be recovered. But equally, the renewable energy systems installed today will provide clean electricity for decades. The protected areas established today will preserve ecosystems for centuries, and the technologies developed today could provide the tools needed to restore damaged planetary systems. We are the first generation to fully understand our impact on Earth's climate system, and likely the last generation with the power to prevent the most catastrophic outcomes. The window for limiting global warming to 1.5 degrees C is rapidly closing, but it has not yet closed completely. The window for preventing catastrophic sea level rise remains open for now, but may not remain so for much longer. The opportunity to preserve large, intact ecosystems and prevent a mass extinction exists today, but every year of delay makes it more difficult and expensive to achieve. The choices we face are not just technical or economic, they are fundamentally moral and spiritual. They force us to confront deep questions about what kind of species we want to be and what kind of world we want to leave for future generations. They require us to think beyond our immediate self-interest and consider our responsibilities to people in other countries, to future generations, and to the other species with whom we share this planet. The climate crisis is ultimately a crisis of relationship. Our relationship with the natural world, our relationship with each other, and our relationship with future generations. For centuries, human civilization has been built on the assumption that we could take whatever we wanted from the natural world without consequence, that we could externalize the costs of our prosperity onto others, and that future generations would somehow solve the problems we created. That era is ending. We are being forced to recognize that we are not separate from nature but part of it, that we cannot prosper while destroying the systems that sustain us, and that we cannot continue to prioritize short-term gains over long-term survival. The climate crisis is teaching us that we live in an interconnected world where the actions of every nation, every company, and every individual affect everyone else. This recognition is leading to profound changes in how we think about economics, politics, technology, and social organization. The old economic model based on endless growth on a finite planet is giving way to new models based on sustainability, circularity, and regeneration. Political systems designed for national competition are being forced to develop new forms of international cooperation. Technologies designed to extract maximum profit from natural resources are being replaced by technologies designed to work with natural systems rather than against them. The transformation is already underway in many places. Renewable energy is now cheaper than fossil fuels in most markets. Electric vehicles are approaching price parity with conventional cars. Cities around the world are implementing ambitious climate action plans. Young people are demanding change from their leaders and choosing careers in fields that address climate change and environmental degradation. But the transformation is happening too slowly and unevenly. While some countries and companies are moving rapidly towards sustainability, others remain locked in fossil fuel dependence. While some communities are building resilience to climate impacts, others remain vulnerable to disasters that could have been prevented or mitigated. While some ecosystems are being restored, others continue to be destroyed at alarming rates. The critical question is whether we can accelerate and scale up the positive changes that are already happening while preventing or minimizing the negative changes that are already in motion. This will require unprecedented cooperation between nations, massive investments in new technologies and infrastructure, and fundamental changes in how we organize our societies and economies. It will require political leadership that can think beyond the next election cycle and make decisions based on long-term consequences rather than short-term political advantages. It will require business leadership that can see beyond the next quarterly earnings report and invest in sustainable practices that may take years to pay off. It will require individual leadership from all of us, making choices in our daily lives that reflect our values and our commitment to future generations. The stakes could not be higher. The difference between the catastrophic scenario and the positive scenario is not just a matter of economic costs or technological challenges. It is the difference between hope and despair, between a future of scarcity and conflict, and a future of abundance and cooperation, between a world where human civilization survives and a world where it thrives. The transition to a sustainable future will not be easy, but it is achievable. We have the technologies we need, or can develop them quickly with adequate investment. We have the economic resources, if we choose to allocate them wisely. We have the human capacity for innovation, cooperation, and sacrifice when we understand what is at stake. What we need now is the collective will to act. This means electing leaders who understand the urgency of the climate crisis and are willing to take bold action. It means supporting companies that are genuinely committed to sustainability while divesting from those that continue to prioritize short-term profits over planetary health. It means making changes in our personal lives that reflect our understanding of the challenges we face. But individual action, while necessary, is not sufficient. The scale of the climate crisis requires systemic change that can only be achieved through collective action. We need policies that make clean energy cheaper and fossil fuels more expensive. We need regulations that protect ecosystems and hold polluters accountable for their environmental damage. We need investments in the infrastructure, technologies, and institutions needed for a sustainable future. We need to fundamentally reimagine what prosperity means in a world with finite resources and a destabilized climate. Instead of measuring success by how much we consume, we need to measure it by how well we protect the natural systems that sustain us. Instead of competing for scarce resources, we need to cooperate to manage them sustainably. Instead of externalizing the costs of our prosperity onto future generations, we need to invest in their well-being. The positive scenario we outlined is not just technically feasible, it is economically beneficial, creating millions of jobs, reducing health costs, and providing energy security. It is socially beneficial, creating more equitable societies where everyone has access to clean air, water, and energy. It is environmentally beneficial, restoring damaged ecosystems and providing habitat for wildlife. And it is morally necessary, ensuring that we leave future generations a world at least as beautiful and abundant as the one we inherited. The path to this positive future is not predetermined. It will require countless decisions by millions of people over the next several decades. Some of these decisions will be made by world leaders in international negotiations. Others will be made by business leaders in corporate boardrooms. Still others will be made by ordinary people in their daily lives. Each of these decisions matters. Each vote cast for leaders who understand the urgency of climate action makes a difference. Each dollar spent on clean energy or sustainable products sends a signal to markets. Each choice to use less energy, eat less meat, or drive less reduces our collective impact on the planet. Each conversation we have with friends, family, and colleagues about climate change helps build the social consensus needed for larger changes. The future is not something that happens to us. It is something we create through our choices and actions. The climate crisis is the defining challenge of our time, but it is also our greatest opportunity to build a more just, sustainable, and beautiful world. We stand at a moment of unprecedented peril and unprecedented possibility. The next 75 years will determine not just whether human civilization survives, but whether it deserves to survive. Will we be remembered as the generation that recognized the crisis and rose to meet it, or as the generation that had all the knowledge and tools needed to prevent catastrophe, but chose not to use them? The answer to that question is not yet written. It depends on what we do next. The story of Earth in the 21st century is still being written, and every one of us is an author contributing to its pages. The pen is in our hands. The blank pages of the future await our words. And the world is watching to see what story we will tell. The children born today will live to see the year 2100. They will inherit the world we create through our choices in the next few decades. They will judge us not by our intentions but by our actions, not by what we said we would do but by what we actually accomplished. We have the opportunity to be ancestors that future generations will thank rather than curse. We have the chance to be the generation that recognized the greatest challenge in human history and found the wisdom, courage, and cooperation to overcome it. We have the power to choose hope over despair, action over inaction, and the long-term flourishing of life on Earth over short-term convenience and profit. The future of our planet, the future of human civilization, and the future of countless other species hangs in the balance. The next chapter in the story of Earth begins now, with the choices we make today. The question is not whether we can create a better future. The question is whether we will. Time is running out, but it has not yet run out. The window for action is closing, but it has not yet closed. The opportunity to be the ancestors our descendants will thank still exists, but it will not exist forever. The story of Earth in the 21st century is the story of whether humanity can learn to live within the boundaries of the only planet we have. It is the story of whether we can transform our civilization quickly enough to prevent the worst outcomes while building something better than what existed before. It is the story of whether love for future generations can overcome the inertia of the present. This is our moment. This is our test. This is our opportunity to prove that humanity is capable of wisdom, not just cleverness, of cooperation, not just competition, of love, not just fear. The future is calling us to be more than we have ever been before. The Earth itself is calling us to remember that we are not its masters but its children, not separate from nature but part of it, not the end of evolution but perhaps its most promising new beginning. The story continues. The future awaits. The choice is ours. What story will we tell? What legacy will we leave? What world will we create? The answer lies in what we do next. Epilogue: The voice of the future. From the vantage point of tomorrow, looking back at the pivotal decades of the early 21st century, one truth becomes crystal clear. This was the time when everything hung in the balance. This was when humanity's relationship with Earth reached its moment of ultimate decision. The voices of the future are calling across time, asking us to remember that every choice echoes through the centuries. They are asking us to remember that we are not just citizens of our own time, but guardians of all time. They are asking us to act not just for ourselves, but for them. In the end, the story of Earth in the 21st century is not really about climate change or technology or politics. It is about us, about who we choose to be when everything we care about is at stake. It is about whether we can find the courage to change, the wisdom to cooperate, and the love to sacrifice for those who will come after us. The future is not a distant place, but a present responsibility. It is not something that will happen to us, but something we are creating right now, with every breath we take and every choice we make. The Earth is still beautiful. The future is still possible. Hope is still alive, but only if we act. The story continues, and we are all its authors. What will you write? Thank you for sharing this moment with me. May your heart feel lighter, your mind at peace, and your night be filled with rest. Don't forget to subscribe, so together we can continue this journey every evening. Until tomorrow, good night.